Good morning. Good morning, all the members of ACCI Managing Committee, student participants, expert committee Sundarao garu, Ramesh Kumar garu, Narasimharao garu, Babu Mahesh garu, Engineer Anil Kumar Pillai, Tirumurti Nayudu garu, and guest of honor Dr. M.B. Shashikirao garu. A warm welcome to you all on behalf of ACCI Kakinada Center. ACCI getting more stronger by expanding their new centers. Last month and this month, ACCI inaugurated 6 new centers and 1 new student chapter and working hard to strengthen civil engineering fraternity. Coming to our centers activity, we have conducted 2 wonderful programs in the last month in the presence of ACCI national leaders. One is student chapter inauguration at Pragati Engineering College, Surampalam, and another is President's Evening with Kakinada Center. Now, I would like to share few memories.
Pragati, progress, and today we are entering into a new dimension of a student chapter. I hereby declare that student chapter of Pragati Engineering College in Kakinada hereby inaugurated. Modeling or BIM software. There's a lot of opportunities are there. If you really love computers, use make these things available to all these students. Let's teach them those softwares and see the miracles are going to happen. And I promise you one thing, I am going to come again to Kakinada, to Rajamundri, and to the same Pragati Engineering College very soon. And I will deliver a lecture on this computational design.
One more video we have.
Opportunities are there. But only thing is, let us not degrade ourselves and charge less. People less than 20 years or 15 years, they are suffering. They are yet to establish.
Youngsters, please never ever think that you know everything. No, even I also don't know everything. He also doesn't know everything. Whenever there is a doubt, talk to the expertise. The ultimate product should not suffer because of your internal ego.
Thank you, Siren. Thanks for your support in every moment of our association activity, even in your exam time also. Thank you, Siren, for making video. Thank you. Coming to today's webinar, deterioration, repairs, and rehabilitation of concrete structures will help the members to acquire knowledge in the various techniques of repairs and rehabilitation of concrete. Now, I invite Dr. K.S. Trimurthinayadu garu to take over the session and continue the session. Thank you very much. Thank you.
Good morning. Good morning, all senior engineers. Audible, sir?
Sir, audible.
Yeah. Good morning, everybody. Senior engineers, practicing engineers, academicians, consulting engineers. A large fraternity with different sections of the engineering faculty are now here. We are happy to share our knowledge, upgrade our knowledge as a civil engineering community. Sir, now Dr. M.V. Shashikirao garu will address a few words. He is a JNTU professor, retired professor from JNTU. He is a retired professor from JNTU. He is a member. He was a member of Service Commission Selection Board and is member of government committee. He is a number of technical bodies. Sir, Dr. M.B. Shashikirao garu, are you there, sir, in the WebEx? Dr. Shashikirao garu? Okay. Let's continue. Our Badam Sundarrao garu will address our session and explain about our priorities of the session, about the concrete durability, building durability. Sir, Badam Sundarrao garu, please continue. Sundarrao garu, please continue, sir.
Yes, sir.
Good morning, sir.
Just
a moment. I'm asking for a share screen.
I request all others to mute the video and mic. Thank you.
Sir, screen is visible, sir?
Yes, sir.
Yes, visible, sir.
Yeah. Now, today's topic is deterioration, retrofitting, and rehabilitation of concrete structures. This is a very important subject. This is becoming more important because lot of buildings are getting deteriorated within the shortest span because of so many practical aspects which the civil engineers are neglecting in the field. First thing, I repeatedly say in my webinars about water quality. Water quality is a very important factor to maintain its durability and strength parameters of concrete structures. Whereas the engineers are more negligent about the quality of water. That is to be taken care by each and every engineer before starting any civil engineering work. Why? Because it plays an important role. Higher chloride contents and higher sulfate contents and higher or lower pH values will cause a lot of inconvenience or deterioration in strength parameters of concrete. So one must be very careful about that structures. And in some cases, actually, the retrofitting or rehabilitation becomes necessary even for healthy structures also, when the structure intended for residential purpose is proposed to be changed to commercial purpose, then the building is to be strengthened. Why? Because the live loads will totally differ. Actually, for residential building, the live load considered will be like 2 kilonewtons per square meter, whereas for commercial buildings, it ranges from 3.3 to 5 kilonewtons per square meter, depending on type of usage. In such cases, we have to strengthen the columns, beams, foundation, and even slabs also. In such cases also, though the building is healthy, in such cases also, retrofitting becomes necessity. And in some cases, what happens is our original IS code says that M15 grade is sufficient for the concrete structures, and all buildings which were about 30 years old are designed for M15 grade. But under present circumstances, M20 grade is minimum grade of concrete, and now in the coming revision, M25 is going to be the minimum grade of concrete. In such cases also, it needs to retrofit the structures. So always the retrofitting and rehabilitation doesn't mean that it is for unhealthy structures. For healthy structures also, sometimes it becomes necessity, and we should be very careful while changing the usage of building. In such cases, we have to recheck our design parameters, and if they are not satisfied with the changed load requirements, then buildings have to be retrofitted. This aspect also all engineers should remember, and I'll conclude within 10 minutes, because our Trimurthul Naidu garu has given me only 10 minutes time.
No, sir. 1
Yes,
minute.
sir.
As you can take 10 minutes or 15 minutes, 20 minutes, sir. Continue, sir. No issue.
Sir. I'll close at a faster rate, sir. Okay.
Not
But
necessary.
yeah.
Continue, sir. No
sir,
issue.
Thank you.
Thank you.
The engineering which involves in modifying the existing buildings for structural behavior without hampering its basic intent of use is termed as retrofitting. Just I am reading out the definition, and I'll go through the explanation later. It becomes necessary to improve the performance of structures, including those facing loss of strength due to deterioration or which have crossed their anticipated lifespan. The realization retrofitting depends on the authentic cause and measures adopted to prevent its further deterioration. This development includes repair, retrofit, renovation, and reconstruction wherever required. Here, always retrofitting may not be the solution. Sometimes total reconstruction may be resorted to. That also we have to consider. There is a 100% retrofitting may not function well. In such cases, the reconstruction is also to be opted. A proper load path has to be analyzed by a structural engineer, and a decision has to be taken if any additional member like shear walls, etc., needs to be added. Here, when that's what I told you in the beginning itself, that if the usage is changed from residential to commercial, the load analysis is to be calculated, and based on that, the retrofitting, to what extent retrofitting is required and what method is fit for that purpose is to be decided, and in some cases, if required, shear walls, etc., can be added. It is the modification of existing structures to make them more resistant to seismic activity, ground motion, or soil failure due to earthquakes. Here, one thing I have to say that our Kakinada or East Godavari, or if you take entire Andhra Pradesh, only from Srikakulam to Yalamanchili, it is in zone 2. The remaining area, the remaining entire Andhra Pradesh is in zone 3 now. But if you take the previous earthquake, zoning, entire Andhra Pradesh is in zone 1. Though the buildings which were designed by the same engineer in 1990 may not be safe now based on the present zoning earthquake zones. Likewise, the wind pressures also changed. Previously, 150 kmph is the wind load taken into consideration, but now for sea coast area, 200 kmph is minimum, and K4 factor, which was introduced recently, is added. That is that K4 factor for sea coast area will be about 1.3. That means that in a simple manner, what we can see is that the wind pressures to be designed are at 260 kmph. So 150 kmph to 260 kmph, there is a drastic increase in the wind calculation. Based on these parameters, if you want to check the structural stability, if they fail, then there are so many methods to retrofit them. So, though the building is presently healthy, but from this changed structural environment, you have to redesign and you have to retrofit the structures. The retrofit techniques are also applicable for other natural hazards such as tropical cyclones, tornadoes, and severe winds from thunderstorms. What are the methods of retrofitting? Adding a new shear wall, adding steel bracing, wall thickening technique, base isolation technique, mass reduction technique, jacketing method, fiber reinforced polymer, and epoxy injection method. What is the advantage of adding new shear walls? Frequently used for retrofitting of non-ductile reinforced concrete frame buildings. The added elements can be either cast in place or precast concrete elements. New elements preferably be placed at the exterior of the building. You can see here, these are the newly added shear walls for making retrofitting. Where we can apply this? For exterior walls, floors, roofs to the ground foundation. Adding steel bracings. It is an effective solution when large openings are required. Potential advantages due to higher strength and stiffness. Openings for natural light can be provided. The amount of work is less since the foundation cost may be minimized and adds much less weight to the existing structure. This is the simple steel bracing which will add more strength without losing the ventilation or lighting. This is a very effective method and most popular method also. To be used in girders during construction, floors framing, used in foundations to reduce bending moment and shear force. Wall thickening technique. Sometimes by simply making the walls thicker, this retrofitting can be done. The existing walls of buildings are added certain thickness by adding brick, concrete, and steel aligned at certain places as reinforcement, such that the weight of wall increases and it can bear more vertical and horizontal loads. And also it's designed for special conditions that the transverse loads does not cause sudden failure of the wall. Here you can see the simple method of doing the thickening of the wall. Where we can apply this? For all RCC buildings, this technique can be adopted. Base isolation. This base isolation method is adopted first in India in Gujarat, Bhuj, during Gujarat Bhuj earthquake. After Bhuj earthquake, this technique was adopted first time in India. Isolation of superstructure from foundation is known as base isolation. It is the most powerful tool for passive structural vibration control technique. This is the method. Applications. It can be applied in residential buildings, buildings of historical importance, monuments, bridges, etc. It was firstly implemented in New Zealand in 1974 and was first enforced in India in 2001 after Gujarat earthquake. LA City Hall, height of about 138 meters in Los Angeles, is the tallest base isolated building in the world. Next is mass reduction technique. In mass reduction technique, for instance, by removal of one or more stories as shown in the figure. This method, it is evident that the removal of mass will lead to a decrease in the loading, which will lead to an increase in the required strength. Yeah, here it is a four-storied building. Because of this failure, what the thing can be done is by reducing one floor, the building can be kept in a safe position. This is the technique which we have suggested for one building in Kakinada, which has got some settlement. But of course, till now the owners has not taken any decision on that. But when the calculations are made, we found that by removing one floor or 1.5 floor, the structure can be kept in a safe condition. This is also a good and ideal method where the retrofitting cost is not to be incurred. In such cases, removal of one floor or two floors, depending on the load parameters and load calculations, this is also an ideal technique. Next is jacketing method. This is the most popular method of strengthening of buildings and columns. There are different types of jacketing: steel jacketing, reinforced concrete jacketing, fiber reinforced polymer composite jacketing. This is the steel jacketing. This can be done very easily, and this is very popular, and without disturbing the total structure, this can be done very easily. And the similar one is with RCC. This is the RCC. This is the most common, and we did this type of work for several old buildings which were retrofitted successfully, and they are performing very successfully. And the same thing is suggested for this building which was supposed to be dismantled behind this Devi multiplex. But unfortunately, that is in court, and till now they have not made any retrofitting. These applications can be for columns, piers, piles, may easily be employed in underwater applications also. Next is the fiber reinforced polymer. It is a relatively new technique to strengthen and repair damage of the structure. The application of FRP in concrete structures is being investigated for its effectiveness in enhancing structural performance both in terms of strength and durability. This is one method, carbon wrapping method. This is also a very popular, and this technique was adopted for fourth bridge, where this road going towards airport to Rajahmundry. For that, there is a small bridge. For that bridge, retrofitting was done with carbon wrapping. And in Kakinada, Hope Hospital building, where first it was designed as for the hotel project. Subsequently, that was converted into hospital. After that, for the hospital people required one canteen building. To accommodate the canteen building, one galvanum sheet structure was proposed by us, and to have that structure, we have retrofitted the beams with carbon wrapping in ground floor, and that performed well. And still now, almost it is a 6-7 years old work. This has given excellent result without disturbing the entire building. By doing simple carbon wrapping, the strength of beam is increased and supports were taken for this galvalume sheet shed, and the canteen is constructed. So this retrofitting means that it is not only for repairs, but where the functional changes are there also these techniques are highly helpful and can be adopted. The applications are guardrails, signboards, drainage systems, bridge decks, auto skyways, utility poles and pipelines for gas, water and sewage, etc. Epoxy injection method. Epoxy injection method is an economical method of repairing of non-moving cracks in concrete walls, slabs and piers. In retrofitting of building, epoxy injection is used to fill and repair the structural fault. This is a simple method and it is very effective where cracks are developed. In such cases, epoxy injection method will be highly helpful and it gives very excellent results. The applications are concrete walls, slabs, columns and piers. And now I am coming to rehabilitation of concrete structures. Since very long researchers have been investigating how to strengthen and rehabilitate the structures, considering the deteriorating state of existing concrete and masonry structures worldwide, it's need of hour to find effective and economical techniques to rehabilitate the old structure. Rehabilitation means to increase mechanical strength and durability. Here, rehabilitation means to increase mechanical strength and durability. Rehabilitation can be measured by evaluating the deformation capacity of various retrofitted components of the structure. It is necessary to know the loadings, both functional and environmental, that the structure will have to withstand in future. So here one should remember that retrofitting and rehabilitation are not separate. They are together. Rehabilitation is the retrofitting is the process of rehabilitation. It means to increase the mechanical strength, tensile strength, that is tensile strength, compressive strength, flexural strength, shear strength, etc. And durability. Durability is a very important aspect. It can be measured by evaluating the deformation capacity of various retrofitted components of the structure. The methods of rehabilitation are graniting, shotcreting, concrete stitching, resin injections, dry packing, polymer impregnation, vacuum impregnation. Graniting refers to an artificial mixture of cement, water and sand that applied to a mold to produce a dense, hard protective layer. Granite is used to line tunnels and structures for construction applications such as ceiling cracks, fissures and areas that could be sources of leaks and structural instability. Here you can see the application of graniting. Where it can be used for ceiling cracks, tunnels, fissures and areas. Shotcreting is a pneumatically applied mortar or concrete on prepared substrates. Shotcrete is also called granite. Concrete applied by spraying. It's a mixture of aggregate and Portland cement conveyed by compressed air to the nozzle of spray gun where water is added. The wet mixture is then sprayed in place and may be carved or traveled almost immediately. This is a photograph of the process. It can be applied for concrete structures, high velocity, primarily on a vertical or overhead surface. Concrete stitching, where the cracks are there, this stitching, like cloth stitching, concrete stitching can be done, and this is also a very old technique, but still it is under usage because of its advantages. It is used at cracks to maintain aggregate interlock and provide added reinforcement to minimize the relative movements of concrete slabs at the cracks. It is also used at the longitudinal joints to keep the slab from separating. Yeah, this is a photograph where this stitching can be adopted. The applications are in CC pavements and in slabs. Resin injection method. It is form of grouting used for repair or reinforcement of underground pipes or tunnels. The process involves the pressurized injection of material into cracks or other defects as part of trenchless rehabilitation efforts. This is the method. Here, plastering is to be removed and the surface is to be cleaned. After that, sealing of cracks and fixing of nozzles with Epomax EK or Epomax L10 or L20 or Durobond or equivalent. Applications are new built projects or existing structures, construction joints. To provide a waterproof curtain behind the structural envelope. In such cases also, this can be used. And the dry packing method. Dry pack mortar is used to repair the concrete surfaces which contains cracks or holes of depth larger than or equal to the least dimension of repair area. The holes generally found on concrete surfaces are cone bolt holes, she bolt holes, she's created by from ties, etc. In such cases, this dry packing technique can be adopted. And applications are tile and brick placement, bed shower installation. And next is polymer impregnation. The pre-polymers are low viscosity liquid monometers are partially or completely impregnated with the pore system of hardened cement composite structure. And this is the method. Applications are bridge decks, irrigation structures, structural members, marine and underwater applications, nuclear power plants, sewage disposal works, waterproofing structures, impregnation of ferrocement products, etc. And now another method is vacuum impregnation. It is also known as porous metal sealing or porosity sealing. Is a process used to seal porosity in metal casting via the application of vacuum pressure. Vacuum impregnation can be effective in eliminating microporosity and macroporosity, where the system to be adopted is always dependent on the requirement. Based on that, the method is to be decided, and this method is applicable for insulation system and metal casting. Thank you. Thank you, sir. Sir, Dr. Trimurthy Naidu garu. Sir, I have completed, sir.
Thank you, Sundara garu. Trimurthy Naidu garu maybe some other work. And now I welcome PCC Ramesh Kumar garu to say a few words or give his presentation on durability of RCC buildings. Ramesh Kumar garu, are you there, sir? Okay, sir. Now I request Kevin Narasimharao garu to take this end. Dr. Narasimharao garu, welcome you, sir.
Yeah, my screen is shared,
Yes,
sir.
yes. ఇప్పుడు sir. I'm Trimurti Naidu here. Hello. Okay.
Yes, sir. Yes, sir. You continue, sir.
Yes. Dr. KVN garu.
Sir, my screen shareable, sir. Visible in the WebEx.
Yes, sir.
Yes. Visible, sir.
Visible, sir. Fine. Shall I start, sir?
Yes, start it, sir.
Sir, 1 minute, sir. Narasimharao garu.
Cheppandi, sir.
Screen sharing not visible, sir. Please share your screen.
Shall I share, sir? నేను షేర్ చేయమంటారా లేకపోతే మీరు చేస్తారా?
ఒక్క నిమిషం సార్, అయిందా చూడండి. నాకు కనబడుతుంది సార్, మీకు కనబడుతుందా షేర్?
No, sir. Yes, sir. It's coming, sir.
కమింగ్ వస్తుందండి.
స్క్రీన్ వచ్చింది సార్.
వస్తుంది. ఫుల్ స్క్రీన్ పెట్టండి సార్, సరిపోతుంది.
ఒక్క నిమిషం సార్.
సార్ దుర్గాప్రసాద్ గారు నన్ను మాత్రం అన్మ్యూట్ లో ఉంచండి సార్. నేను సెషన్ జరుగుతున్నప్పుడు మ్యూట్ చేసుకుంటాను.
సార్ నాది కనబడుతుందండి స్క్రీన్?
కనపడుతుంది సార్, విజిబుల్. వెరీ గుడ్.
ఫైన్ సార్.
ఒక్క నిమిషం సార్ నరసింహరావు గారు, ఒక్క నిమిషం మీరు మ్యూట్ చేసుకోండి. ఇప్పుడు మనకి అసోసియేషన్ ఆఫ్ కన్సల్టింగ్ ఇంజనీర్స్ వాళ్ళు ఈ సెషన్ లాంచ్ చేశారు. చేసినప్పుడు టెక్నాలజీ షేరింగ్, అప్గ్రేడేషను, స్టూడెంట్ చాప్టర్స్ లేకపోతే ప్రొఫెషనల్ చాప్టర్స్ గురించి చాలా బాగా ఎక్స్ప్లెయిన్ చేశారు. ఈ ప్లాట్ఫామ్ వాళ్ళని థ్యాంక్స్ చెప్తున్నాను. ఐ విల్ ఫ్యూచర్లో కూడా మంచి ప్రోగ్రామ్స్ ఇలా చేద్దాం సార్. నెక్స్ట్ ఇప్పుడు బాదం సుందరరావు గారు సెషన్ రిట్రోఫిట్టింగ్, రిపేర్స్, రికన్స్ట్రక్షన్, రిహాబిలిటేషన్ బిల్డింగ్ మీద చాలా డీటెయిల్గా మనకు ప్రజెంటేషన్ ఇచ్చారు సార్. యాక్చువల్గా వాళ్ళకి బాదం సుందరరావు గారు అయితే అంత డీటెయిల్డ్గా టెక్నికల్గా ఇచ్చింది 1 hour కాదు, 2 hours అది కంప్లీట్గా ఒక 1 day సెషన్ కూడా సబ్జెక్ట్ మ్యాటర్ ప్రజెంట్ చేశారు సార్. ఐ థ్యాంక్ సుందరరావు గారు. సుందరరావు గారితో నెక్స్ట్ ఒక డీటెయిల్ సెషన్ ఎప్పుడన్నా ఓన్లీ అని సుందరరావు గారు పెట్టుకుందాం సార్. లైవ్ కూడా పెట్టుకుందాం సార్. నౌ ఐ వెల్కమ్ డాక్టర్ నరసింహరావు గారు. సార్ నరసింహరావు గారు కంటిన్యూ చేయండి సార్. నేను మ్యూట్ అవుతున్నాను. నరసింహరావు గారు కంటిన్యూ చేయండి సార్.
వెరీ గుడ్ మార్నింగ్ టు ఆల్. My name is Dr. Narasimharao, Chief Technical Advisor, Akriti Consultants, Kakinada. Today I am going to present a webinar topic on centering of concrete structures with fiber reinforced polymers. To the exact, it is the FRP centering.
సార్ చిన్న నరసింహరావు గారు
చెప్పండి సార్.
మీరు ఎంత టైం అయినా తీసుకోండి సార్, డీటెయిల్గా చెప్పండి. అందరూ మనమే ఉన్నాము. ఇట్ ఈస్ వెరీ ఫ్లెక్సిబుల్.
రైట్ సార్, థ్యాంక్ యూ. 1 hour టైం ఇవ్వండి సార్, నేను చెప్తాను.
అంటే ఫుల్ టైం తీసుకోండి సార్, ఎంత టైం అయినా పర్వాలేదు, అందరూ మనమే ఉన్నాము.
రైట్ సార్, ఫైన్, థ్యాంక్ యూ. ఐఎమ్ కంటిన్యూయింగ్. వెరీ గుడ్ మార్నింగ్ టు ఆల్. My name is Dr. Narasimharao, Chief Technical Advisor, Akriti Consultants, Kakinada. Today I am going to present a webinar topic on center of concrete structures with fiber reinforced polymers. That is, to the exact, it is the FRP centering. This is my part of presentation on today's webinar topic, that is deterioration, repairs, and rehabilitation of concrete structures. At the outset, I would like to thank the organizers, Shareforce Group, and the Managing Committee of Association of Consulting Civil Engineers, Kakinada Center, who encouraged me in presentation of this today's webinar topic. And I would also like to have the special thanks to my professor, Dr. Subbarao sir. Under his able guidance, I am doing my second doctoral research. This is topic of presentation is part of my review of literature pertaining to my research work. Thank you, sir. Before going to the in-depth understanding of the FRP concepts, let us first of all see what is the historical background of the fiber reinforcements. These fiber reinforcements are not new to the world. It is existing from the ancient times. Once we look at into the Hindu temple Agama architecture or the Agam Shastras, there is a cementitious material called as Ashtabandhana, which is constituting of 8 different materials. One among them is the fibrillated material that is in the form of, they've termed as Yarabatti. They have impart the tensile strength to the cementitious material of Ashtabandhana. This is the ancient historical evolution of the fiber reinforcements is considered. That was the fibrillated material that was used as Ashtabandhana in the ancient Hindu temple architecture is considered. When coming to the medieval, we have the Egyptians, that was a application is there, in which they used the traditional straw as the reinforcement in the mud building construction to minimize the drying shrinkage. That is, after the construction of any building is there with mud, we have problem with the drying shrinkage. To control that, as a intuitive technique, they have adopted this technique of what we call introduction of this fiber to the mud. That was the medieval application we can see. But coming to the scientific evolution, Japanese are the first one who introduced this concept, that is in the form of retrofitting of a building structure that was seismically damaged. As a part of forensic structural engineering, they want to analyze the building structure, and they found that the building was under design, and they want to have the retrofitting of the building. For that retrofitting of the building, they tried with the FRP ramping system, and that was the first application in the modern engineering bodies concept. That is, we can see the ancient application is from the Ashtabandhana to the modern application of retrofitting is through Japanese, where they retrofit with the columns of a building structure. This concept of FRP is not new to the world. In the classical theories of elasticity, we have a problem with the friction beams, in which the traditional timber structures are sandwiched with the steel plates. That is, the wooden joists that was there, that was sandwiched in between the wooden plates. The external one will be the steel plates, and the internal will be a wooden joist. That may be a distressed wooden beam or a new beam. To strengthen that wooden beam, the steel plates was used. This is called as a pitch beam concept. This is the traditional centering material that we have in the classical theories of elasticity as the center materials is considered. That same concept was adopted in the development of FRP systems. That is nothing but the FRP system is not new, the concept wise, but the technology, there is a lot of improvements that leads to a drastic evolution, especially in the engineering part of this question. Next, this is the theoretical background and also the practical background of the present problem. That is, we are talking with respect to the FRP centering. Before going to the in-depth understanding of the FRP concepts, we'll see what is the necessity of a centering system of a building, and also what is the exact requirement of FRP centering. That basic understanding is to be very essential to have the credits tool that is going to the FRP system of centering. Yeah, we have concrete is there that was cast. It is subjected to various deteriorative mechanisms, like the deterioration can be with respect to the chlorides, or it can be in the form of sulfates, or it can be in the form of carbonation, or phasing point cycles. This was the most critical in the foreign countries. And we have the alkali silica reaction. These are also very detrimental to the concrete service life of the structure. Whenever a concrete is designed in a structural system, that system of concrete has to sustain up to the your service life of the building. That is, what is the design service life of the structure is there. Up to that, the design service life of the structure, the building has to sustain. The figure that is on the top hand corner shows the response of the performance versus the surface life of the structure. That is, the performance can be in the form of a strength requirement or a durability requirement that is to be performed during its service life. That is nothing but the design service of the building that is expected to be. That may be 100 years in the case of a bridge structure, or maybe a 75 or 60 years for a building structure. Up to the design period of the building or the structure, the building has to.
ఏదో పెట్టారు కానీ ఊరికే అందరినీ మరి ప్రాపర్ గా ఇన్వైట్ చేశారు
సార్ నేను కొద్దిగా ప్రెజెంటేషన్ చేస్తున్నాను సార్ దయచేసి కొద్దిగా the figure shows that the response of the performance of the building with respect to the service life of the building. The curve shows that there is a original demand that is with respect to the service life, with respect to the performance of strength and the durability, that is going to degrade with respect to the degrading elements like what we have mentioned earlier. This degradation will lead to the loss of the service life of the building. And in some cases, there is a necessity of increasing the strength of the building, even though there is a no deterioration or detrimental effects to the strength and durability of the building. The building has to be performed in a much more superior way. That is, there should be a strength requirement, like in the case of a bridge structures, where we require the additional strength for the loading requirements. For example, suppose the bridge was designed for a class A loading or class B loading. In some cases, the bridge is required to be upgraded to class A or class 70 unloading. In such a case, the bridge is required to be retrofitted for the sectional point of view or shadal point of view. In such a case, there is an increase in the demand with respect to the original demand to the new demand requirements. Therefore, this curve shows what is the exact requirement of the FRP systems. That is, one is with respect to the when there is a decrease in the service life of the building with respect to the a degradation with respect to original demand, and also there is a increment in the original demand that is required to a new demand requirement that is in the form of the additional strength requirement. That is what the building is expected to be more than its performance level. And the most figure shows that the deterioration due to the products. Sir, is it audible, sir?
Audible, sir. Audible, sir.
My
Yes, sir. Yes, sir.
voice is somewhat sneezing, sir. Please tolerate me. I try to cover the bit. The bottommost figures are showing that the chloride ion diffusion corrosion, which is the most susceptible corrosion in the world that is facing too. That is, we have entire world is almost covered with the sea coast. In India too, we call it as a Peninsular India, the Jambu Dvipa in the ancient times, in which we have the largest sea coast. The first one is the Gujarat sea coast. After that, AP is the second highest sea coast we have. The chloride ion diffusion is much more effective and in the determination of the detrimental effect of the any building structure is considered. That is, the damage when compared to other type of degradations like sulfates or carbonation. Carbonation is also there in combination with the chlorides. But when compared to alkali silica reactions and freezing and thawing, the chloride deterioration, that is the concrete structures are facing, is much more rapid and it's at an alarming stage. Therefore, this is the need of the hour and the need of the day to have the webinar of this today's presentation. And the right hand top figure shows the chloride ion penetration at the initial stages, that is the initiation, and we have the subsequent propagation. That shows that the figure shows that clearly there is a steep rise in the chloride initiation stage to the its propagation level. That is, we have to prevent the ingress of chloride ion diffusion. And once it was entered into the concrete member, the propagation is very rapid. That we can understand. Therefore, what are the FRP methods we have is nothing but to have the strengthening of the existing members that was degraded. Also, to have the retrofitting of the members that was degraded due to various environmental effects. That is in terms of the durability point of view is considered. Yeah, fine. We'll see what is the exact reasons of the strengthening requirements of any structure is considered. Just now we have seen the degradation effects and the necessity of fiber reinforcement strengthening, and also the new strength requirements that is with respect to FRP strengthening system is considered. And now we see what are the strengthening of the structures requirement with respect to various other purposes, like when there is an increase in the load carrying capacity. Just now we have discussed a bridge was designed for a class A loading or class B loading, and subsequently it is required to be upgraded to higher loadings of class A or class MTR. In such a case, the bridge is required to be retrofitted. Or when the building is intended for the change of use, or change of use nothing but originally it was designed for any residential application. Now that was modified for the institutional point of view, like any mercantile or institution, like hospitals and etc. In that, there is change of class of loading is there as per the IS 75 Part 2. That is the code pertaining to the live load is considered. Whenever there is a change in the live load classification, definitely it imparts the what is the stress level requirements in terms of the various structural actions of considered. That is the columns, beams, including the foundations and the slab system, has to survive for the additional loading requirement in terms of increased live load that is coming on the structure. That is, increase in the load carrying capacity. That is, whenever there is a change in the loading class on the structure, the building is required to be redesigned and strengthened. And also, when there is a change in use, like there is a change in the functionality of the building, such a case also, we have to strengthen the building. New load conditions. That is, whenever there is a new load conditions, like there is a change in the
రాజు గారు అన్మ్యూట్ చేయండి. యువిజే రాజు గారు అన్మ్యూట్ చేయండి.
whenever there is a change in the load conditions, like just now Sundar Rao has discussed that there is a change in the IS 875 Part 3, like introduction of the K4 factor, which is the available factor from the Japanese code itself in the ancient times. Like,
రాజు గారు మ్యూట్ చేయండి. యువివి రాజు గారు మ్యూట్ చేయండి.
this K4 factor is there earlier in the Japanese code, but it was introduced in 2015 version of IS 875 Part 3 as a factor that represents the topography and general region conditions, the cyclonic effects of the any costly regions of India. These any load conditions or any change in the wind loads, like we have earlier 875 Part 3 is there, the 1987 version that has a different wind load conditions are there. We have new code of 875 Part 3 is there. That is 2016 version, I think so. That has a different wind load is coming. Whenever the building is designed previously for one loading, it's the same code by the same designer for same site conditions or the same exposure conditions. But change of code with respect to the IS code, that leads to a new load conditions that requires to be, if the building is to be redesigned for the new strength requirements. In the US and all that European countries, they're adapting of the philosophy of seismic hazard strengthening requirements. That is also comes under the category of new load conditions. In such a case, what they require is they will analyze the existing structures for the what is the seismic hazard susceptibility, and based upon if the building is found to be vulnerable to the seismic activity of the corresponding zoning and the loading requirements of the structure, such a case, what will they will do is they will retrofit the structure using the seismic retrofitting method. That comes under the new load conditions. When coming to the design of construction, it is also whenever there is a change in some structural modifications, like removal of columns or some beams, that generally going on in India without the consideration of the structural units. In such a case, in a later date, it was found that with any structural experts or the designer, the building is required to be strengthened. In such a case, this retrofitting the strengthening with the existing structures is the point of consideration. And replace capacity loss due to damage or deterioration. Just now we have discussed. I don't go in detail of this point. That is, deterioration can be any environmental degradation effects, chlorides or sulfates, etc. All these deterioration requires the strengthening of the structure. Corrosioning of the steel reinforcement. This corrosion is again, especially due to the chloride ion corrosion. And if any degradation is there with respect to degrading factors, subsequent corrosion due to the chloride ion is much more significant. And sometimes there will be cutter damage at the reinforcing steel. Due to the opening requirements of some sort of piping line requirements or for the placing of appurtenances in industrial structures, that requires the some sort of openings in the existing RC structures, or say we can say in the slabs, That requires the openings in the slab that leads to loss of some steel reinforcement, and there is a propagation of the tensile cracks into the concrete job. That requires and impact damage. This impact damage is nothing but whenever we are mounting some sort of equipment on the floors of the building that was not intended for. Generally, even though it's an institutional building, say mercantile building, that was converted to some part of that as a industrial purpose. In such a case, there is a possibility of happening of some impact equipment. In such a case, the case with the industrial structures, when there is a damage with the impact point of view of impacting machinery like the cyclopeding or any drop hammers like that will create damage to the floors and the surrounding structures. In such a case also the method of settling is much more important. Fire and other hazards. Whenever the building is subjected to a fire hazard, immediately after the fire hazard, the structural strength development is there. After the evaluation of the strength parameters, if the building is required to be strengthened, then the strengthening requirement comes into picture. And the last two requirements are increased seismic performance of the structures and the blast resistance. These are two important parameters, are the necessities of the strengthening of existing structures are considered, especially with respect to FRP strengthening is considered. That is, the much more application we can found in the blast resistant structures and also in the seismic performance of these structures. The basic concept of FRP was designed initially was with respect to the seismic performance requirements. That is, just now we have discussed, Japanese has developed this technology for the strengthening of existing columns which was subjected to a seismic damage. And this FRP retrofitting for seismic point of view is much more effective when compared to other type of systems. And blast resistant existing strength requirement is nothing but whenever there is a possibility of the blasting is there due to some terrorist attack or enemy's attack. In such a case, the building is subject to substresses. Generally, the building is not designed for the substresses. If the building is anticipated or supposed to be designed for the blast resistant design, in such a case, the seismic retrofitting techniques are the combination with the blast resisting techniques will come into picture. The speed is continuable, sir, or shall I slow the speed?
Continue, sir. Continue, sir. Continue, sir.
Fine, sir. Fine, sir.
But
These are the traditional methods we have. Like before going to the advanced methods, this FRP system of centering is a very, very advanced method of centering. And before going to that, we see the traditional methods of centering. That is in the form of we have bonded steel plates and bolted or epoxy bonded steel plates, external post tensioning systems, and external stressing systems. These are the various systems we have. To strengthen the existing distressed any strengthening requirements. That is nothing but just so we have discussed this switching concept in which the steel plates, so in between the steel plates, the wooden beams are sandwiched. In similar concept, whenever there is a certain requirement is there in a conventional way, the bottom of the girders of the any bridge deck are the bridge girders, are maybe the case of a building bottom beams or the slabs will be bolted with the steel plates. This concept is nothing but what is the extreme fiber stresses that was there in the bottommost fiber of the structural member. What is the section member? Is the beam here is giving the tensile stresses that is extreme pressure tension to the bonded steel plate or bonded steel plate. This steel plate can be bonded or bolted. That deviates or that differentiates the type of application. That is, if it is bonded with any epoxy, it is called as a bonded steel plate. If it was bolted, it is called as a bolted steel plate. If it was used with both systems of epoxy and the bolted system, it is called as a bolted or epoxy bonded system. Like we have the other types of centrifugal methods are there. That is external force tension system. That the bottommost corner, we are seeing that the bottom of the transverse heaters was retensioned with the force tension with the steel cables after the loss of any resistance. Generally, after the during the performance of the sector, there is a possibility of loss of resistance due to the creep and shrinkage effects.
డాక్టర్ కేవీఎన్ గారు హలో సార్, మీ వాయిస్ బ్రేక్ అవుతుంది సార్.
Break out, నాకు కొద్దిగా రొంపగా ఉంది సార్. I will try to speed up the presentation, sir.
బ్రేక్ అయి వస్తుంది సార్ మీ వాయిస్ మీకు.
1 minute, sir. 1 minute. Now audible, sir? Sir, now clear ఉందండి?
ఇంటర్నెట్ ఏమైనా ప్రాబ్లం ఉందా సార్ మరి?
సార్ క్లారిటీ ఉందండి ఇప్పుడు?
ఇప్పుడు పర్లేదు సార్.
Sir, now the application is with respect to the bonded steel plates. ఇప్పుడు బాగానే ఉంది సార్?
ఇప్పుడు బాగానే ఉంది సార్.
Like we have bonded steel plates and we have the bolted bonded steel plates. These are nothing but the bottom of the girder is the bonded steel plates are nothing but it was bonded to the bottom of the girder with the help of any bolted system or the epoxy system. The external post tensioning after the loss of any resistance or any due to losses of the resistance, these resistances can be introduced as a new one in the form of post tensioning, that is in the form of external post tensioning. The external stressing is also nothing but the similar concept. We are like giving the additional stresses after the completion of the structure due to loss of this.
సార్ డాక్టర్ కేవీఎన్ గారు కొంచెం వాయిస్ లౌడ్ గా చెప్తూ కొంచెం స్లోగా చెప్పండి, బ్రేక్ అవుతుంది. కొంచెం స్లోగా స్టడీగా చెప్పండి సార్. అంటే నెట్ కనెక్షన్ ఏదో ప్రాబ్లం ఉన్నట్టుంది మీకు, కొంచెం స్లోగా చెప్పండి సార్. వాయిస్ బ్రేక్ అవుతుంది.
సార్ ఇప్పుడు క్లారిటీ ఉందండి?
ఇప్పుడు క్లారిటీ ఉంది సార్, కొంచెం ఇప్పుడు క్లారిటీ ఉంది.
Yes, this is a conventional system we have. ఇప్పుడు ఎలా ఉంది సార్?
నెట్ ప్రాబ్లం అనుకుంటా సార్, మీది బ్రేక్ అవుతుంది సార్.
స్లో ఉంది సార్ కొద్దిగా. సార్ ఇప్పుడు
అదర్ మొబైల్లో ఏమైనా మ్యూట్ చేయండి సార్, ఇంటర్నెట్ స్టాప్ చేయండి సార్ అదర్ డివైస్ నుంచి. మొబైల్
కాదు సార్, మొబైల్ ఆఫ్ చేశాను. సార్ ఇప్పుడు ఎలా ఉందండి?
ఇప్పుడు పర్లేదు సార్, కొంచెం
ఇప్పుడు పర్లేదు సార్, కొంచెం బాగానే ఉంది. కంటిన్యూ సార్.
ఒకసారి తిరుగుతున్నాడు. నెక్స్ట్ స్లైడ్ కొద్దిగా ఫార్వర్డ్ చేయండి. ఫార్వర్డ్ అవుతుంది.
స్లైడ్ అండి,
నెక్స్ట్ స్లైడ్ ఫార్వర్డ్ చేయండి.
నేను షేర్ చేయమంటారా తీసేసి?
మీరు షేర్ చేయండి ఒకసారి. అది మధ్యలో డిబేట్ అయింది. రైట్ సార్, నాది కరెక్ట్ అయింది సార్. తిరుగుతున్నాడు కరెక్ట్ అయిందండి సార్. సార్ తిరుగుతున్నాడు కరెక్ట్ అయింది.
Continue.
Fine, sir. We have seen the different traditional applications of the FRP systems. These FRP systems are nothing but the conventional method of doing the this sandwich technique of the beams. That is, we are externally bonding the steel threads to the your concrete structures. Now we see what are the different types of FRP materials and the basic definition of the FRP. This basic understanding is necessary to understand the further behavior of the FRP materials. Basically, a fiber reinforced polymer is a two-component material. One is in the form of a fiber reinforcement, and the second one is in the form of a polymer that was in which the fibers are embedded, and the fibers will be acting as a one member that was bonded in between the polymer. The matrix we call as. This polymer will protect the environmental degradation and the other effects of the fibers. Thereby, it gives the some protecting to the fiber reinforcement. The main strength component is coming from the fiber reinforcement, whereas the external resin or the external matrix is to bind all the fibers that are there in the constituent. That is, in the drugs, we have two components. One is in the form of fiber reinforcement, second one is in the form of a resin matrix, which constitutes the total fiber reinforced system. And the
వాయిస్ బ్రేక్ అవుతుంది సార్.
వాయిస్ ఇంకా బ్రేక్ అవుతుంది కేవీఎన్ గారు.
నాయుడు
సార్,
నరసింహరావు గారి వాయిస్ కొద్దిగా బ్రేక్ అవుతుంది. నువ్వు చెప్పినట్టుగా కొద్దిగా స్లోగా ఉంటే బాగా ఇది వెరీ ఇంట్రెస్టింగ్ సబ్జెక్ట్, వెరీ వాల్యుబుల్ సబ్జెక్ట్. ఓకే ప్లీజ్. వాయిస్ బ్రేక్ అవుతుంది సార్.
కంటిన్యూ చేయండి సార్. కొంచెం స్లోగా చెప్పడం కూడా స్లోగా చెప్పండి సార్.
హలో
కేవీఎన్ గారు, వినపట్టలేదు. హలో, వినపట్ల. నాట్ ఆడిబుల్. ఆడిబుల్ కాదు సార్.
హలో
లేదండి, వినపడుతుందండి కేవీఎన్ గారు. కొంచెం స్లోగా చెప్పండి. వాయిస్ కూడా బ్రేక్ అవుతుంది. ఇంకా కూడా కంటిన్యూ చేయండి. స్లోగా చెప్పండి. నెట్ కనెక్షన్ ప్రాబ్లం అండి. స్లోగా చెప్పండి, పర్వాలేదు. కంటిన్యూ. ఎందుకంటే ప్రజెంటేషన్ ఉంది కాబట్టి కొరెలేట్ చేసుకోగలుగుతాము. కొంచెం స్పీడ్ తగ్గించి స్లోగా చెప్తే బ్రేక్ అయినా వినపడుతుందండి. ఓకే సార్.
సరే. We have different types of polymer applications are there. These are nothing but FRP rods and the laminates and also the fabric materials. Each one is having the different applications. Like in the case of a FRP rods, these are generally applicable for the case of reinforcement in RCC structures. Whenever there is a possibility of severe corrosion is there, in such a case, these FRP rods are better suitable. Like in the case of marine structures, the corrosion is the main problem of consideration. In such a case, the FRP rods are much more effective and will give much more higher design life of this structure. When coming to the laminates are nothing but these are the sheets of the FRP materials generally used for the flexural strengthening. That is, whenever there is a requirement of seismic retrofitting, the conventions and the requirement with respect to loading is there. The beam strengthening is generally done with the sheets in the form of laminates. And other type of application is in the form of fabrics. These fabrics are generally applicable in the case of a wrapping systems that is generally used for the column confinement point of view. That is, whenever the column or the beam junction point column confinement is required, in that case, wrapping is the most effective method of system of FRP retrofitting. Around that?
నో a little bit better అండి. a little bit better. బాగుంది. కొంచెం స్లోగా చెప్పండి, బ్రేక్ అయినా అర్థం అవుతుంది.
We see now what are the advantages of FRP. FRP materials, the basic structural engineering advantages are it is having very high strength and high fatigue resistance, non-corrodable, non-conductivity, and low weight and ductility. These are the structural advantages we have, based upon which we can develop the FRP systems. That is, these structural advantages led to the development of fast development of the FRP systems. The steel and that has a high fatigue resistance and non-corrodable test. We have discussed it is when there is a possibility of chloride ion diffusion is there and chloride ion degradation is there. In such a case, it is better to adopt a FRP bars instead of a conventional steel bars to have the design of this structure and also to minimize the weight stress. And the conductivity is considered. We have some issues with respect to the that we are designing like hospital buildings. In the case of hospital buildings nowadays, we are using the MRI equipments. These MRI equipments are nothing but the magnetic resonance application is that these magnetic resonance applications will lead to some sort of magnetic conductance. Once we use the steel reinforcement in the concrete, that will have the conductivity. That conductivity will interfere with the magnetic fields of the MRI equipment. Therefore, in such a case, instead of going with the conventional steel reinforcement, it is better to have the use of FRP rods or FRP materials as a reinforcement. And low weight. Typically, the weight is 1/3 the weight of the conventional steel materials. Being a lightweight materials, once we adopt for any retrofitting, the initial load that is coming in the form of a overlay, generally in the case of conventional retrofitting, we use it as a overlay. That is the additional number thickness, the jacketing we provide, that will create some sort of dead load. That as an additional factor, it will reduce some sort of dead load stresses. To minimize that, the dead load component should be as minimum as possible. From that FRP materials, once we use it, that will be an excellent system of giving the minimum weight of load weight to the structures. This is about 1/3 of the weight of the conventional concrete materials. The weight is about the density is 1.2 gram per cc. Generally, the concrete is having 2.4 or 2.5 gram per cc or 25 kg per meter. So this is having 1.4 to 1.5 kg per meter square. That depends upon the density of the your FRP system. Regarding the ductility, FRP materials are basic advantage that was gained as popularity is based upon pertaining to the property of ductility. The being very highly high strength materials and also the having the high tensile. These materials, when used for the confinement purpose, especially for the beam columns or for the column confinement purpose, that gives a good ductility to the structural members. Generally, for the columns and the beam column junctions, ductility will be a problem. The seismic is a requirement. In such a case, we can issue the structural ductility through FRP systems. This is the applications with respect to the structural engineering part of it, the advantages with respect to the structural engineering point of view. And seeing the other advantages like constructability advantages and other advantages. These advantages are nothing but low profile requirements. That is nothing but whenever there is a conventional retrofitting is there, that requires a lot of equipment like sandblasting equipment, chipping equipment, so much of laborious procedure is there. That much of serious procedure is not there with respect to the FRP system. Within days, 1 or 2 days, the entire system can be completed with a low cost. It's low cost in the terms of not only with respect to the materials, that process of involvement with respect to the lab.
నరసింహరావు ఒక్క నిమిషం సార్. మీ దగ్గర ఉన్న ఏదైనా ఇన్స్ట్రుమెంట్ మీ వాయిస్ ని రిపీట్ చేస్తుందా?
లేదు సార్, నేను మొత్తం క్యాంపస్ స్విచ్ ఆఫ్ చేశాను.
ఏదైనా మైక్ కానీ మీ వేరే ఫోన్ లో మీ వాయిస్ రావటం కానీ పక్కన ఏదైనా ఇన్స్ట్రుమెంట్ ఉందా సార్?
సెల్ ఫోన్స్ ఉన్నాయి సార్, తీసేయమంటారా?
తీసేయండి సార్, ఎందుకంటే మీ వాయిస్ రిపీట్ అవుతుంది, ఎక్కువ వస్తుంది, పైగా యాక్సిలరేట్ అయిపోతుంది. చాలా మంచి సబ్జెక్ట్ చెప్తున్నారు, ఎక్కడో తేడా ఉంది సార్. అందరూ ఎగర్లీ వెయిటింగ్ టు హియర్ యువర్ వాయిస్.
ఇప్పుడు ఎలా ఉంది సార్?
సార్ మళ్ళీ మాట్లాడండి.
ఎలా ఉందండి?
కొంచెం బాగుంది సార్. నెట్ కనెక్షన్ వేరే ఏమన్నా ఉందా సార్ మీకు? వేరే కనెక్షన్ ఏమన్నా మార్చడానికి ఉందా?
ఇప్పుడు ఎలా ఉంది సార్?
కొంచెం ఇంప్రూవ్ అయినట్టే ఉంది సార్. ఏదైనా ఇన్స్ట్రుమెంట్ ఆఫ్ చేశారా? మీ డెస్క్టాప్ లో ఏమన్నా అది వాయిస్ సౌండ్ ఎక్కువ పెట్టి ఉందేమో చూడండి. మీ దగ్గర సౌండ్ తగ్గించుకున్నా పర్వాలేదు, మీ వాయిస్ బాగానే వస్తుంది. ఇప్పుడు చూడండి సార్, ట్రై చేయండి. అదేదో ఎక్కువ వచ్చింది అనిపిస్తుంది.
సార్ ఇప్పుడు ఎలా ఉందండి? మైక్ మార్చాను. ఎలా ఉందండి?
మరొకసారి మాట్లాడండి.
ఇప్పుడు ఎలా ఉంది సార్? ఇప్పుడు బాగానే ఉందండి.
అలాగే బ్రేక్ వస్తుంది సార్.
సార్ ఇప్పుడు ఎలా ఉంది సార్ వాయిస్?
నెట్ ప్రాబ్లం అయి ఉంటుంది సార్. బ్రేక్ వస్తుంది సార్ మీ వాయిస్. హలో,
ఎలా ఉంది సార్?
ఇప్పుడు కొంచెం ఇంప్రూవ్ అయిందండి.
సార్
ఇప్పుడు కొంచెం పర్వాలేదు సార్.
ఇప్పుడు ఎలా ఉంది సార్?
పర్వాలేదు సార్, ఇవ్వండి సార్, కంటిన్యూ సార్. సార్ కంటిన్యూ సార్.
ఇప్పుడు ఎలా ఉంది సార్? బాగానే ఉందండి.
ఇప్పుడు బాగానే ఉంది సార్.
సరే. Yeah, regarding other advantages are considered. These are the low profile defects. The install thickness is generally less than 1.5 mm. That leads to a minimum dead load to the structure. And they can be easily considered with the top course, right? Suppose if any evidence requirements are there, we can use some sort of cookies and other to cover the FRP repair system. And using this top course, we can have the entire response of the country ensured with the FRP system. And in the case of conventional system, we have the problem with ugly look and all the top of the completion. This is fitting is concerned. And just now we have discussed this minimum equipment requirement. A simple angle grinder, cutting machine, and some sort of towers and all that. All of a sudden, minimum equipment, we can complete the entire work. Does not add any appreciable dead load to the structure. That is also we have discussed just now. What are the various FRP materials that was used in the actual structural engineering application? This understanding is also necessary for the selection of appropriate FRP materials. Why? Because the properties of the different FRPs are different. Depends upon the your structural requirement, that is loading requirements of whether it is a seismic fitting or the carbon strength requirement, or the actual stress requirement is considered. Depends upon the application point of view and also the loading requirement point of view. You have to select a suitable FRP material so that it will be suitable or appropriate for the given design requirements are concerned. Generally, there are a variety of FRP materials are there. Most popular one will be the carbon fibers, glass fibers, and aramid fibers. And the fourth one is also somewhat of importance, that is the basalt fibers that is generally used for the FRP blocks making. Carbon fibers will be having the very high strength, generally used for the beam strengthening, and also the sometimes the carbon fibers are used for the shear strengthening of the beams. When compared to the glass fibers, these are the best application for the lab purposes. And regarding the carbon fibers, the working with carbon fibers is very difficult to work with, even for cutting up 8 inches by 8 inches of diameter sheet. It takes 5 minutes of time. There is a toughness problem with there with respect to the carbon sheets and carbon fibers. Therefore, upward of your carbon fibers is somewhat difficult. Yeah, these are the general different types of FRP materials that was generally used in the structural engineering context. This point also we have discussed in detail. High strength requirements of the FRP and high stiffness, extent durability and endurance, and the use of mechanical strengthening applications. Now we are discussing the characteristics of different types of fibers. That is, just now we have discussed the importance of the carbon fibers and the importance of the glass fibers and the importance of the carbon fibers. Different fibers will have different applications, and each one is constituting its structure and behavior differently. These different structure and behavior led to the understanding concepts should also be understood in a different way. That is, the strength requirements is to understand, and the stiffness requirements is to understand, and also the durability and endurance is to be understand for a given FRP material is concerned. When coming to the carbon is very having very high tensile strength. The tensile strength is generally 5 times higher than that of the steel. The Fe 450 or the Fe 500 steel, when compared to that, these carbon fibers will have a strength of nearly about 2,500 megapascals to 3,000 megapascals. Almost 5 to 6 times higher than the strength of the conventional steel material. Stiffness. The stiffness also is very high, especially the elongation. These are basically elastic materials. Unlike the steel material, which is an elastic material, the stiffness of the FRP, especially the carbon, is very high when compared to other types of FRPs. Excellent durability and endurance. This endurance property is nothing but durability is the property against the environmental degradation. Most of the fibers are the polymer materials susceptible to UV degradation. Once they were protected from the UV degradation, they were excellent durable. And regarding the endurance point of view is considered, we have to consider the creep behavior. That is, the selection of the fiber type is also a function of the creep behavior of the material. Creep is the behavior under the sustained load. That is, under the sustained stress, the material is subjected to a constant strain at the increased strain. That is the property of the creep. The creep materials are to be taken into consideration while finalizing the carbon fibers. Generally, for the creep point of view, these carbon fibers are best when compared to these glass fibers. Whenever the creep is not a problem, in such a case, we can go with the glass fibers. If the creep is the problem, being a higher creep distance, carbons will be the better alternative. Some loadings, like the seismic loadings and all that, we have the short-term loadings, like transient loading, with the fraction of seconds to fraction of minutes, less than 2 to 3 minutes. In such a case, creep might be a problem. Therefore, seismic retrofitting point is considered. Either we can have an option of both carbon fibers and the glass fibers as a point of selection. But this should be in connection with the what strength requirements of the FRP system is considered. And the applications point of view is considered, we'll discuss in the next session. For majority applications, these materials are suitable. Regarding the conductivity is considered, glass is having very conductive material similar to any metal substance. Once we look at it into the periodic table, it has the conductivity similar to the any metal. So where there is conductive problem is there, like electrical conductivity in the structure or due to the magnetic conductivity in MRI units and like that. In such a case, we should have the limitation on the carbon fibers or carbon FRP systems. And when coming to the exact requirement of such a generic application, the flexible strengthening applications of the beams generally carbon fibers are more suitable. And when coming to the glass fiber, this is also in parallel with the carbon fibers as an advantages, but the only problem is with the cream. Just now we have suggested. That is, the glass fibers will be subjected to more amount of cream. That is, they were highly prone to cream behavior. Therefore, only under transient loadings like seismic retrofitting due to earthquake loading, or any loading certain requirements are there. In such a case, only these glass fiber retrofitting is suggestible. The basic advantage with the glass fibers is they were non-conductive, hence whenever there is a conductive application restrictions are there, glass fibers are the best suitable option. And regarding the stiffness is somewhat lower when compared to armament and also when compared to glass fibers. But it has a somewhat good stiffness, but the basic stiffness is somewhat lower when compared to armament and carbon fibers. Regarding the matrix components considered, the matrix plays a very important role in transferring the stresses from the parent structural member, that is the parent RCC beam, to the even fibers. Actually, the fibers are the load carrying members are the stress components that is taking the entire system. But to come to the stresses to the fibers, it has to be transferred to the matrix. The matrix will in turn transmit from the parent material of RCC to the fibers. Therefore, the strength of the matrix plays an important role. We have different types of matrix components are there. These are nothing but polymers, silicones, ceramics, methacrylate, methyl ester, polyamide, geopolymers, phenolic, and epoxy. Among these different types of polymers, we have epoxy and vinyl esters are generally used as matrix component for the secondary point of view is considered. Epoxies are the most suitable for the carbon applications, that is for the carbon fibers, and vinyl esters are generally used for the glass fibers. These epoxy plays an important role, or the matrix plays an important role, not only with respect to the strength transmission between the material to the fibers. It also acts as a binding material between the your FRP system and the your parent structural member. That is the bond between the interface bond between the structural member and the FRP composite will be very essential in transmitting the loads. That is the straight combat between. We must, otherwise there is a debonding. To minimize the debonding, we generally use these matrix support very high good interface shear strength. That is, it should have very high strength of the material in terms of the shear strength is considered. We'll see the exact methodology and the concept of FRP systems. In the FRP systems, we have two components of this. One is in the form of a parent structural member. Second one is the FRP material that was grouped to the bottom of the extension fiber to the beam of concrete or the beam, and it can be a steel beam also. Generally, we are discussing with respect to the RCC beam. The external FRP system is bonded to the bottom extreme fiber of the RCC beam. Once it was glued or attached to the RCC beam, it will act as a one member with the RCC beam. That is, there is a strain compatibility between the extreme fiber of the RCC member and the composite FRP system. This will act as a unison, that is as a one member, and it will as a combined effect similar to friction beams. It will take the entire sectional action, that is the moment of resistance. The moment of resistance is coming from the two components here. Here we have two systems. One is in the form of FRP laminate, and the second one is the form of RCC beam. Using these two components, the entire is coming from. That is, the moment of resistance of the system is nothing but the moment of resistance of the FRP composite and the moment of resistance of the original RCCP. We conventionally we are deriving the consensus from the steel reinforcement. If it is not corroded, then the steel area is effective. If it is corroded steel, there is some sort of loss of area of steel is there. Under the loss of area of the steel, it has a new movement of resistance that we call as a residual strength. This assessment of the residual strength in the case of a FRP something is much more important. Otherwise, we won't lead to economical situation with respect to FRP design is considered. Therefore, we have to exactly find out the what is the residual area, the net area that is available in the form of a steel in the degraded RCCP or the RCC column, and based upon that we have to find out the your limit of resistance, that is nothing but the distance of the steel into the corresponding area of the steel that multiplied by your limit of distance, that is the limit of resistance of the bridge. That coupled with the the tension offered by the FRP system, that is the number of layers into the layer thickness into the width of the FRP, that multiplied by with respect to the CG of the concrete in the compression zone. This combined system will give the movement of resistance. And the left hand figure shows that a measurement of the steel reinforcement of the corroded steel specimen using 3D optical scanners. This is the latest technique we have. Using we can find out what is the net available steel area, that is we can the concrete, using which we can find out the residual strength of the concrete member after degradation or degradation. This is very important parameter to assess the residual strength of the member. That is in coupled with the total system will offer the total moment of resistance. The bottommost figure is nothing but a moment elevation relationship that is in the form of a of the load with respect to the midspan deflection. That is part of some research work. This was the behavior that was found. And there are three figures that was showing in the curve. Yellow one, black one, and the red one. The yellow one that is pertinent to a corroded specimen with some sort of area of decapacity reinforcement. The black one is with respect to a controlled specimen that is without any corrosion. And that one is a system that was with some sort of corrosion and strengthened with the system. Once we take it into the point as a uncontrolled, uncontrolled specimen, we compare the black once there is a 20% degradation in the steel area, there is a drastic decrease of 50% in the load carrying capacity. That is, here we are measuring the load deflection curves. The load applied at the midspan is in the 2-point loading, similar to a flexion loading under the 2-point test. The midspan at the deflections are measured with that LVDT equipment. Once we measure the load segment response, there is a drastic 50% reduction in the load is considered when it is approximately 50% degradation of the area of the transport. Once we compare this specimen beam specimen moment elevation relationship to the FRP settling system improvement, leads to there is an increase of 400% improvement is there. That concludes that the FRP system is much more the advantages and efficacy in improving the load carrying capacity, that is the moment of resistance. That is almost a 150% can be improved with respect to the personal uncorroded beam specimen, and an increase of 400% that can be attributed to when compared to a specimen of corrosion with the 50% or 20% corrosion that was there in the steel reinforcement of the. Therefore, these load deflection curves gives a qualitative assessment of the improvement of the FRP settling efficacy. And just how we have discussed this debonding effect. Debonding is the strain at which there is a separation between the laminate with respect to the bottommost fiber of the rigid beam. That is the corroded beam or the uncorroded beam, as the case may be. We are using the FRP laminate at the bottommost extreme fiber as a external bonded material, and once the stiffness increases, there is an increase in the strain in the FRP laminate, and also there is increase in the tensile strain in the extreme fiber of the tension fiber of the beam. And there is a strain at which that strain is approximately 1.4 to 1.6%. That strain we call as a characteristic strain at the deep point strain, which governs the strength of the laminate.
స్పీచ్ క్లియర్ లేదు సార్, ప్లీజ్. నర్సరావు స్పీచ్ బాగోలేదు, అసలు వినిపించలేదు సార్, ప్లీజ్.
సార్ ఒకసారి టెస్ట్ చేసి మళ్ళీ కంటిన్యూ చేస్తారు సార్. హలో, బాగానే ఉంది సార్ ఇప్పుడు? హలో,
ఇంకా క్లియర్ గా లేదు సార్, క్లియర్ గా లేదండి.
ఒక్క నిమిషం సార్. ఇప్పుడు ఎలా ఉందండి?
కొంత రైట్ పర్లేదు, ప్రాబ్లం లేదు సార్, కంటిన్యూ చేస్తాం సార్, చూద్దాం.
ఇప్పుడు ఎలా ఉంది సార్? ఇప్పుడు ఎలా ఉంది సార్? బాగానే ఉందండి.
లైట్ డిస్టర్బెన్స్ ఉంది, పర్వాలేదు, ఎందరైనా పర్వాలేదండి.
సరే, కొద్దిగా ఇది నెట్ ప్రాబ్లం సార్, మెయిన్ ప్రాబ్లం.
కొంచెం స్లోగా చెప్పండి సార్.
సరే. This concept of understanding of the FRP behavior. ఇప్పుడు ఎలా ఉంది సార్? హలో,
ఏదైనా డిస్టర్బెన్స్ ఎక్కువగా ఉంది సార్, డిస్టర్బెన్స్ చాలా ఎక్కువగా ఉందండి.
ఇప్పుడు సార్? హలో సార్,
బ్రాకెట్ల కింద.
హలో సార్,
స్లోగా చెప్పండి సార్, కొంచెం అర్థమవుతుంది. ఈ వాయిస్ డిస్టర్బెన్స్ ఉన్నా కూడా అర్థమవుతుంది.
ఇప్పుడు ఎలా ఉంది సార్? ఇప్పుడు బాగానే ఉందండి.
నేను ఇప్పుడు
గొంతుగా కొంచెం బొంగురుగా వస్తోందండి.
గరగరలు బాగా ఎక్కువగా ఉన్నాయి సార్, గరగరలు ఎక్కువ ఉన్నాయండి. మరి ఒకవేళ లైన్లో ఎవరైనా మ్యూట్ చేసి ఉంచారని చూడండి ఒకసారి. లేకపోతే
అలానే ఉంది సార్.
సార్ కంటిన్యూ చేయండి, ప్రాబ్లం మళ్ళీ మెసేజ్ చేస్తాను, కంటిన్యూ చేయండి సార్, నో ప్రాబ్లం.
కొన్ని హెడ్ ఫోన్ తీసి ట్రై చేయండి.
అది బెటర్ సార్, హెడ్ ఫోన్స్ తీసి ట్రై చేయండి.
ఇప్పుడు ఎలా ఉంది సార్?
మోరల్లెస్ అలాగే ఉందండి.
హలో
సార్, కంటిన్యూ చేయండి సార్.
సార్, ఇప్పుడు ఎలా ఉందండి?
మేబీ స్లైట్లీ బెటర్.
సార్ మీరు ఫోన్ లో మాట్లాడండి సార్, లేకపోతే ఫోన్ లో మాట్లాడితే బాగుంటది. మన హనుమంతరావు గారు ఎవరైనా ఆయన స్లైడ్స్ తిప్పుతారు లేకపోతే ఒకసారి. సార్ లేకపోతే మీరు డైరెక్ట్ ఫోన్ లో మాట్లాడండి సార్, స్లైడ్స్ వేరే వాళ్ళు తీస్తారు, మీరు ఫోన్ లో మాట్లాడండి సార్ ప్లీజ్. సార్ మీటింగ్ కంటిన్యూ చేసేది బాగుంటుంది సార్.
తిరుమతి నాయుడు గారు, హలో. తిరుమతి నాయుడు గారు,
సార్ తిరుమతి నాయుడు గారండి?
హలో తిరుమతి నాయుడు గారు.
వినపడుతుంది, చెప్పండి.
సార్ మీటింగ్ కంటిన్యూ చేద్దాం సార్.
కంటిన్యూ చేసేద్దామండి. నా వాయిస్ వినపడుతుందా?
మీది వినపడుతుంది సార్.
వినిపిస్తుంది సార్, వినిపిస్తుంది, క్లియర్ గా ఉందండి.
అయితే నేను ఇప్పుడు నెక్స్ట్ చెప్పండి.
చెప్పండి.
నెక్స్ట్ అనిల్ కుమార్ పిల్లే సిమెంట్ వాటి మీద కొంచెం చెప్తారండి. వారిని ఇన్వైట్ చేస్తానండి.
చేయండి.
రైట్. అనిల్ కుమార్ పిల్లే గారు, హలో.
Good afternoon to all of you. Am I audible?
ఆడిబుల్ అండి, వినపడుతుంది పిల్లే గారు.
Okay.
మీరు స్టార్ట్ చేస్తారా? మీరు షేర్ చేస్తారా మీ పీపీటీ?
I'll share. I will just a minute.
స్టార్ట్ చేయండి సార్ మీరు.
Yeah.
థ్యాంక్ యూ. Anil Kumar Pillai is the representative from Ramco Cements. He is a technical person. He is a South India head. Is well acquainted with all the cement and durability conditions, PPCs, blended cements, and so on, microstructure and everything. Is a well-known person in the cement industry. Sir, please, Anil Kumar Pillai garu, continue. Thank you.
Thank you. You're able to see my slides?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes,
At
yes,
any
yes.
point of time, if you are not able to hear me, please feel free to stop me.
No, yes, you can, visible, sir. You continue. Visible, continue.
Yeah. Just- So the thing is that, the topic is very interesting and I have been given 10 minutes, I believe. The topic is on durability.
Sir,
And
sir,
when we-
sir, Pillai garu, you feel free.
Yeah.
Take 10 more minutes, no problem, no issue.
Okay.
No issue. Okay.
Okay. So the thing is that we are talking about durability of concrete structures. So when we talk about durability of concrete structures, what is it that we are trying to say? We are trying to look at the lifespan of the structures, because durability in effect means that we want to have a longer life for the concrete structures that we are constructing. So when a designer or a civil engineer or a concrete technologist wants the concrete structure to have a longer life, he needs to give more importance to durability. So different structures are designed accordingly. Some of the structures like residential structures would be around 50 to 70 years, maybe more than that. Concrete rigid pavements maybe 30 to 35 years. Concrete bridges maybe up to 100 years. High-rise buildings more than that. And monumental structures, which is being designed to have a lifespan of more than 200 or 300 years, things like that. So idea is that based on the lifespan of the structure, the durability of concrete structure has to be designed, and it has to be ensured that whatever is required is implemented at site. So that is one very important thing that we need to keep in mind, because ultimately every client, every customer, every institution wants the lifespan of the structures to be longer and to be as per the designed one. Now, to come to the specific topic of why blended cement. Now, when we talk about blended cement, we know that blended cement means either Portland pozzolana cement or Portland slag cement, wherein some kind of blending material is being added. We had this ordinary Portland cement, as all of us know, which started with ordinary Portland cement 33 grade, then it came 43, 53 grade and things like that. But the idea of blending or adding some pozzolanic material like fly ash or slag started long back. It is a practice which has been there from time immemorial. And the reason is that we need to have this kind of adding or blending, not only from the environmental point of view, but also from qualitative perspective. And as all of us know, the Indian cement industry as of now has more of blended cement, like more than 80% of whatever the cement is being produced in our country is of the blended cement. It could be either the Portland's pozzolana cement or Portland slag cement. So the idea behind having this blended cement is that there are certain kind of benefits that one will get, in the sense that whatever free lime is being generated due to the hydration of ordinary Portland cement with water can be taken care of by the blending material. As all of us know that cement hydration, it produces CSH gel and calcium hydroxide. So that calcium hydroxide is what we call the free lime. So that calcium hydroxide is not considered to be conducive to concrete structures. So that free lime or free calcium hydroxide needs to be taken care. And that is where the pozzolanic material, reacts with this and then takes care of arresting the production of more free lime. You cannot entirely do away with free lime, but you can limit the production of free lime or calcium hydroxide and enhance the impermeability of CSH gel. Heat of hydration can be brought down, because the thing is that, as all of us know, ordinary Portland cement 53 grade although it has a high rate of gain of strength, also has a high heat of hydration. Now in blended cement, that heat of hydration can be taken care of. That heat of hydration can be lowered because of the addition of this blending material. Cement paste permeability, as I was telling, that the CSH gel can be made more impermeable. And as all of us know, our IS 456 in the latest amendments has been talking about various kinds of attacks. It can be either the chloride attack or the sulfate attack for concrete structures. Now, those kind of attacks can be prevented or can be avoided by the usage of blended cement, and that is the recommendation that is being given even in the IS code also, saying that blending materials will help in the prevention of deterioration of concrete due to chloride or sulfate. Now, what exactly is this pozzolanic material? As all of us know, pozzolanic material is nothing but they are inert material by itself. But when it comes, like say for example, if you take the case of a very good fly ash, which is a pozzolanic material, when it comes in contact with free lime, it gets activated. So that is how the pozzolanic material is being defined as. And the role of pozzolana, as I was telling, is to bring down the heat of hydration, to arrest the free lime, and to take care of the cement, enhance the cement paste permeability, and to make it more impermeable. So that is the reason we as concrete technologists should not be confined to a type of cement alone. If I say that let us use Portland pozzolana cement or Portland slag cement or ordinary Portland cement, 33 grade of course is not available nowadays, 43 grade, 53 grade, we need to understand where are we using, what is the application, and what is the requirement of concrete. Only after that, we need to specify the type of cement. So it is, we need to understand the concrete properties and then specify the right product for right application. Now that is what one needs to do, because then we will be able to sort out many problems if we are able to understand the requirement of concrete. Because very often we have seen under practical considerations, sometimes the same mix design will not be applicable for a concrete which is flowable and which is to be delivered at the site, within the shortest span of time. For the same M20 grade of concrete or M30 grade of concrete, you can have different mix designs based on how it is going to be transported. Is it going to be transported for about 2 hours? Then in that case, we need to design the concrete mix for 2 hours slump retention. If it has to be used immediately, then it has to be designed accordingly. So for the same grade of concrete, we will find that there is something called, the mix design, which has to be customized based on the specific requirement. So that needs to be paid attention. So in that perspective, whether you are adding a blending material in cement or concrete, or whether you are using blended cement, the idea is the same. This is how the durability of the concrete structures can be taken care of. Now, the thing is that it is not that only due to the usage of blended cement, you can have durability. It has to be complemented with good concreting practices, especially many of the parameters that we talk about concreting, the aspect related to lower water cement ratio, because if the water cement ratio is not lower as per the grade of concrete, then you will find that you can have the kind of problem that is there. Although here in this slide the water cement ratio is mentioned as 0.7 or 0.6, it is recommended that we do not use those water cement ratios at all, because 0.6 water cement ratio, when you go to the fields, when you go to the sites where volumetric batching is followed, there is no control over water cement ratio, and that is where many of the problems occur. You will find that there is something called the honeycombing in concrete. Aggregates are seen outside. In spite of so many programs that has been conducted by various professional bodies in our country, we will find that almost many of the construction practices that is there, especially not the project construction I'm talking about, the unorganized sector, is having this problem of maintaining a good quality control in concrete at site. That is basically because we all have been, used to this kind of thumb rule. There is this thumb rule that is being followed by the masons at the site, saying that based on the estimation of the workability I am using the water cement ratio. He doesn't know how much exactly he is using. He may use up to 0.6 or 0.7, due to which, the durability of the concrete can be affected. And the other thing is, as far as practices is concerned, we talk about the curing period of concrete, which is a very important parameter to ensure that the concrete is durable, it has a longer life. So when we talk about concrete durability, we are talking about the usage of blended cement, usage of blending materials, following good concreting practices, especially water cement ratio, curing period. And the most important thing is we talk about the usage of chemical admixtures. Now, when we are using chemical admixtures, it is very important that we do sufficient number of trials at site. So that is how we can maintain the durability of concrete and things like that. So without that, I don't think so. We can maintain the durability of concrete. So I thought that I will share this very important aspects as far as durability of concrete is concerned. This is what we can take over from here. We can do a lot of work as far as concrete mix design is concerned. We can look at the economical mix designs, because economical mix designs, when we are talking about, there should not be too much compromise on cementitious material content, because many times we are not looking at the exposure conditions. The exposure conditions with respect to what we have in IS 456, ranging from mild, moderate, severe, very severe, extreme conditions. So many times what happens is that even for the same grade of concrete, irrespective of the exposure conditions of concrete, you will find that a minimum cement content is being added, sometimes 300, 320, because if you look at the extreme conditions of exposure, 300 or 320 kg per cubic meter is not the right cementitious content. It has to be enhanced, it has to be increased. So those are the considerations that we need to keep in mind to ensure the concrete is durable. And even when we are going in for a higher grade of concrete, say for example M50, M55, M60, and we will find that the upper limit of cement content is 450 kg per cubic meter. Now, to take care of that 450 kg per cubic meter of cement content, we have to add cementitious content. And now that cementitious content is nothing but the blending materials that we are talking about. So when you are using blending materials, you can go much beyond the 450 kg per cubic meter of cement content that is being mentioned in the IS code. So blending materials can be used, provided we have the facilities for checking the quality of blending materials at site, or a better option would be to use blended cement. So that is what we thought, we would give more attention to this. So thank you, Association of Consulting Civil Engineers, for having given us this opportunity to interact with all of you on this Sunday afternoon. And I am sure that talks like this would generate a lot of discussions, dialogues amongst each one of us. Thank you, Naidu Garu, for having given me this opportunity on behalf of Association of Consulting Civil Engineers. Thank you so much.
So Anil Kumar Pillaji has presented very nice effect of the blended cement, blending material, pozzolanic activity, reactive powders. It may be slag, it may be fly ash, it may be reactive silica. Order of the day is the durability of the. Sir, am I audible?
Sir, you're audible. You're audible.
Yeah.
You're audible.
Sir, audible, sir.
The order of the day is our Pillaji has correctly presented it. We are good at achieving strengths. M30, M40, nowadays all the engineers are well practicing, they are well experienced. Order of the day is the performance and durability of the structures. So rightly presented, is it the structure is durable for 70 years or 100 years or 150 years? So what are the parameters? What are the factors we have to look into? So what is the things we have to do, whether OPC or PPC or PSC or some other blended cement? So what is the need of the award? Durability is the need of the award, performance is the need of the award. For that, which type of blending has to be done, which type of cement has to be used? We engineers have to well acquainted, we have to study in detail, let us exchange all our ideas. Aptly presented by our Anilji, free lime, which is very deleterious material, very dangerous material, calcium hydroxide. It causes leaching action. and secondary pores, seepage pores, and water ingress or other impurities ingress, rusting of the reinforcement, all these things because of the free lime. So let us in the next session, our next meeting, our live meeting also, let us work with Anil Kumarji and like-minded people who are doing work on it, and our all doctorates or research faculty members and academic members also. So we will let us continue in the live meetings or live sessions also about blending of the cements, reactive powders, durability, performance, silica, and so on. CE sir, Ramesh Kumar sir, R&B CE garu, Ramesh Kumar, are you there sir? CE R&B Ramesh Kumar garu. Sir. CE Chief Engineer R&B Ramesh Kumar garu is there in the meeting. He talked to me that he will Chief Engineer Ramesh Kumar garu, R&B Chief Engineer. Are you there, sir? He talked to me that he is in the meeting. He joined. Okay, let us continue with our Babu Mahesh garu, who is a senior person in the cement industry. He has done a lot of work on it. He is good at cement, its behavior, repairs and rehabilitation of structures, and so many active fields. Sir, Babu Mahesh garu, continue your presentation, sir. Babu Mahesh garu.
మీరు షేర్ చేస్తారంటే షేర్ చేయమంటారా?
మీరు చేసేయండి సార్, మీకు రాకపోతే నేను చేస్తాను. మీరు చేసేయండి. ఓకే.
తిరుమల నాయుడు గారు
చెప్పండి 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 చెప్పండి.
నాకు అవ్వట్లేదు, మీరు చేయండి సార్.
ఒక్క నిమిషం, ఇప్పుడే చేస్తాను. సార్ దుర్గా ప్రసాద్ గారు, సార్ నన్ను ప్రజెంట్ చేస్తేనే ప్రజెంట్
మిమ్మల్ని ప్రెజెంటర్ చేశారండి.
ఓకే సార్, నౌ ఐఎమ్ షేరింగ్. ఓకే సార్, షేర్ అవుతుందండి.
డిస్క్లైమర్ అని వచ్చింది.
షేర్ అవుతుంది సార్.
ఓకే నెక్స్ట్ సార్, క్యారీ ఆన్ సార్.
ప్రెజెంటేషన్ మోడ్ లో పెట్టండి సార్. అది
ప్రెజెంటేషన్
సార్ బాబు మోహన్ గారు,
ఓకే
బాబు మహేష్ గారు
సార్ సార్ చెప్పండి
మీరు
సార్.
కాపీ రైట్లు పెట్టేసుకుంటే ఎలాగా మాలటోళ్ళు కాపీ చేయాలంటే వీలు లేకుండా మాకు కాపీ రైట్ ప్రొటెక్షన్ ఇలాంటివన్నీ పెడితే మాలటోళ్ళు ఏమైపోతామండి.
ఇస్తాను సార్, మేము కూడా కాపీ రైట్స్ ఇస్తాం సార్ మీకు.
కంటిన్యూ సార్,
కంటిన్యూ.
సార్ ప్రజెంటేషన్ మోడ్లో పెట్టండి సార్.
ప్రజెంటేషన్ మోడ్లోనే ఉంది సార్ ఇప్పుడు, లేదా?
లేదు సార్.
ప్రజెంట్ చేయండి సార్. F5 ప్రెస్ చేయండి.
కాదు సార్, ఇక్కడ కిందన
F5 అండి.
F5
ప్రెస్ చేయండి సార్. F5.
ఓకే సార్.
F5 చేస్తారు మీకు తెలుస్తుంది. షేర్ అయిపోయింది కదండి. F5 నొక్కండి సార్.
F5 నొక్కానండి. ఓకే, స్లైడ్ షో. స్టాప్ షేరింగ్. సార్ ఇప్పుడు వచ్చిందండి.
ప్రజెంటేషన్ మోడ్లో రాలేదు సార్.
ప్రజెంటేషన్ మోడ్ ఇప్పుడు
రాలేదు సార్.
F5 ప్రజెంట్ చేశాను సార్. F5 నొక్కాను. F4 F5
హోమ్ బటన్లోకి వెళ్ళడం ఒకసారి.
హోమ్. ఓకే ఓకే.
కింద ఆప్షన్స్ ఇవ్వట్లేదు.
ఇవ్వట్లేదు సార్ వీడు.
కింద
సార్ F5 కాదండి, కిందన నోట్స్ ఉన్నాయి కదండి, అక్కడ చూడండి ఈ 75% అని చూపించింది దాని యువతల ఒక చిన్న బొమ్మ కనబడుతుంది. అదే అండి, అది దాని పక్కది సార్. ఎస్ సార్.
వచ్చిందండి ఇప్పుడు.
వచ్చింది.
ఓకే సార్.
కాదండి,
వచ్చిందండి ఇప్పుడు.
ఓకే అండి, వచ్చిందండి ఇప్పుడు.
ఓకే సార్. ఓకే, కంటిన్యూ సార్.
వెరీ గుడ్ మార్నింగ్ టు ఆల్. సార్ వినపడుతుందండి?
వినపడుతుంది సార్.
ఓకే ఓకే ఓకే. Very good morning to all the panel members of today's webinar and expert committee members and members and budding engineers from Association of Consulting Civil Engineers, Technocrats, Institutional and Industrial Clients, academicians and the other participants of today's webinar. A warm welcome you to all the today's webinar. Today I am going to speak about the concrete deterioration and transport mechanism in concrete structures. Sir, next. మూర్తి గారు, శ్రీమూర్తి నాయుడు గారు,
చెప్పండి
సార్. స్లైడ్ మూసేయండి సార్.
స్లైడ్స్ మూసేనా?
నాకు అవదండి, మీకే అవుతుంది సార్.
ఓకే ఓకే, కనపడుతుందండి ఇప్పుడు.
కింద యారో. ఓకే, కింద యారోస్ ప్రెస్ చేస్తూ ఉండండి, సరిపోతుంది. ఏమండి?
అలాగే.
ఓకే. Today I am going to speak about concrete deterioration and transport mechanism in concrete. Before going through this topic, we must need to know about the basic principles of performance of a structure. The performance of a structure is defined as consequence of action to which it is subjected or which it generates as a function and as a consequence of its interaction with the environment. The performance of a structure, it is prescribed that the structure and structural members shall be designed and constructed and maintained such a way that they perform adequately and in economically reasonable way during construction and its service life. In this framework, I'm going to address to all the structural engineers, designing engineers on three categories of performance, that is serviceability, structural safety, and sustainability. Serviceability, it means the structure must be fit for its use and has to be such as to perform adequately under service consideration.
ఏంట్రా ఇక్కడ
The combination of action expected during its service life of its normal use. Then we consider structural safety. It means ability of a structure and its structural members to guarantee the overall stability, adequate deformability, and ultimate bearing resistance. The next, responding to the action which is assumed in the design both under persistence combination, under accidental or exceptional situation, and these performance have to be guaranteed with an appropriate level of reliability. And finally, sustainability. It means ability of a material, such structural member shall be structured to contribute positively to fulfill of the present needs of humankind with respect to nature, society, and humans, without compromising the ability of future generation to meet their needs in a similar manner. Those three categories must be keep in mind during the design of the structures. But in current practice is concerned, it is very hard to achieve the fulfill of those three categories of performance due to inadequate knowledge about the interaction of the material at which exposure conditions during the design phase. And second one is compromising with the quality of the concrete and lack of good construction practices, which leads to structural failure. Next.
మహేష్ గారు వాయిస్ బాగా లోగా ఉంది సార్, వాయిస్ వినిపించలేదు అసలు.
సార్ బాబు మహేష్ గారు వాయిస్ వినపట్లేదండి. హలో,
ఇప్పుడు వినిపిస్తుందా సార్?
నాకు వినిపిస్తుంది, నాకు వినిపిస్తుందండి. ఇప్పుడు ఓకే సార్, ఓకే సార్.
నెక్స్ట్ సార్, నెక్స్ట్ స్లైడ్.
ఓకే సార్.
In recent studies shows that many buildings that are collapsed and damaged to various degrees with a single reason of concrete deterioration. In that 40% of structure failures are reported that with the reason of corrosion of the embedded steel reinforcement in the concrete. In this subject regards, I am going to show few case studies which are recently reported at various locations. This is NBCC Society building at Gurgaon, New Delhi. This is 5 years old building, recently reported at in many social medias and all. So next. So this project was started in 2012 and work was completed in 2017. As for the findings, many structural cracks found in the building because of substandard material have been used for this construction. And recently, central government passes an order to the residents how to vacate the building as it is not safe for living conditions. These total RCC elements get deteriorated due to deterioration of the concrete with various reasons. In second case study, this is 10 years old apartment building at Guntur. You can see the column failures in this picture. In third case study, in this case of Guntur apartment building, we can find the wide vertical cracks on the column at the cover crate location and falling of the plaster work over the column and disintegration of the cover crate and corroded steel reinforcement was seen inside the column during my physical verification. In third case, in this case, there is a five-story building suddenly collapsed at 8:30 p.m. in the East Delhi. In this case, one of the reasons was reported that seepage from the surface drain and salts stored might have weakened the load-bearing concrete column. Capillary rise of the salt ions into the concrete from the ground floor gave way to the corrosion of steel at the beam column junctions. Next. The main causes of failures reported that groundwater might be used for this construction without any testing of groundwater. In this regard, I am going to note you all the engineers in recently, not in recent, in many cement firms are come up with very good technical services department that they are providing to the very good services in testing of the water and cube casting at the site. Please, I request you all the engineers to utilize these services for better construction of the durability of this structure. And second one is environmental exposure conditions are not taken into the consideration. And poor quality control and bad construction practices have been reported in the above said cases. Next. Why such failures happen? Inadequate knowledge about the interaction of the material at various exposure conditions during the design phase that leads to poor selection of the material. And another one is codal provisions on durability designs are not implemented even though they are prescriptive approach. Next. So in our traditional BIS code is based upon the prescriptive based approach. They have given the durability aspects, the subdivision is given in the exposure conditions like mild, moderate, severe, very severe and extreme conditions. But that is a prescriptive based approach. Experience from the practices shows that routes based on the combination of experience, research, and institution have a lot of drawbacks on this prospective approach, often resulting in a not adequately durable design. There is a lagging of implementation of the code of practice in reality. Next. Prescriptive based approach has some limitations. There is no reliable prediction of structure, service life, and inadequate description of environmental conditions. There is no clarity on classification of environmental conditions. And other codes like Euronorms and Australia standards and FIB model codes, these are there is a very clear definitions about the classification of the environmental condition. Now, BIS come up with a very good classification system in our upcoming IS 456. They are incorporating carbonation effect in our upcoming model code. First, to make some perception toward the cement and concrete. Chala varaku chala perceptions ఉన్నాయండి ఈ విషయంలో. The ordinary Portland cement is better for construction. Yes, it is correct because of faucetting. As per the Bureau of Indian Standards, the blains, minimum blains has to maintain 225 blains. But many cement many cement firms are maintaining 322, 324 blains, almost all equal to RHPC blains. So because of to give better quality of the blended cement to the customers, సో ఈ పార్ట్ మీరు అండర్స్టాండ్ చేసుకోవాలి. సో ఎందుకంటే ఆర్డినరీ పోర్ట్లాండ్ సిమెంట్ ఇస్ ద మెయిన్ కన్స్టిట్యూయెంట్ ఇన్ ద మేకింగ్ ఆఫ్ బ్లెండెడ్ సిమెంట్. టు fulfill the user requirement, cement firms are come up with very good blends to fulfill the user needs. సో బ్లెండెడ్ సిమెంట్స్ హ్యావింగ్ ఏ స్లో సెట్టింగ్. సో ఈ ప్రాబ్లం అయితే ఇప్పుడు లేదండి. ఇది బ్లెండెడ్ సిమెంట్స్ ఫర్ ప్లాస్టింగ్ వర్క్ అండ్ ఓపీసీ ఫర్ ఆర్సీసీ వర్క్స్. So after this presentation, we come up with very good solution on this point. Durability and other engineering properties are function of FCK. This is another wrong perception. So ఎవరైనా కస్టమర్ వెళ్ళినప్పుడు నాకు సాయిల్ కండిషన్స్ బాగాలేవని అంటే కొంతమంది ఇంజనీర్స్ దే ఆర్ ఆప్టింగ్ ఫర్ హైయర్ గ్రేడ్ ఆఫ్ కాంక్రీట్ లైక్ M30 and M40. So that is very wrong perception. So next, if cube strength is okay, then concrete structure is fine. So idoka another wrong perception. So strength and durability అన్నది రెండు different aspects కాబట్టి సో ఈ పాయింట్స్ కూడా మనము మన నోటీస్ లో ఉండాలి. నెక్స్ట్, కాంక్రీట్ ఇస్ ఫర్ విల్ టేక్ కేర్ ఆఫ్ ఇట్ సెల్ఫ్. సో కాంక్రీట్ మనం ఏది తయారు చేస్తే అది మొత్తం అంతా కాంక్రీట్ బేర్ చేస్తుంది అనుకుంటాము, కానీ అది కాదు. సో ఇన్ దిస్ పాయింట్ ఆఫ్ వ్యూ వీ నీడ్ టు టేక్ ద కన్సిడరేషన్ ఆఫ్ ద స్కిల్ ఇన్ లేబర్ అన్నది కూడా మనం కన్సిడర్ చేసుకోవాలి. నెక్స్ట్, ఫర్ బెటర్ వర్కబిలిటీ యూజ్ మోర్ వాటర్. ఇది ఒక రాంగ్ పర్సెప్షన్. సో చాలా మందికి వరకు ఇది పాయింట్ తెలియదు. ఫర్ బెటర్ వర్కబిలిటీ యూజ్ మోర్ వాటర్ అన్నది చాలా రాంగ్ పర్సెప్షన్. సో ఇన్ మార్కెట్ దేర్ ఆర్ లాట్ ఆఫ్ admixtures are available in like a water reducers. We need to go for the type of admixtures and put into the practices enough to make the waterproofing at the top of the slab. ఇది ఒక రాంగ్ పర్సెప్షన్. సో ఇక్కడ చూస్తున్నాం, ఇక్కడ వాటర్ సిమెంట్ రేషియో గురించి మనం మాట్లాడుతూ ఉన్నాం. ఈవెన్ పిల్లయ్య గారు కూడా ఈ పాయింట్ ను బాగా స్ట్రెస్ చేశారు. వాటర్ సిమెంట్ రేషియో అనేది చాలా ఇంపార్టెంట్ ఫ్యాక్టర్. డ్యూరబిలిటీ ఈస్ కన్సర్న్. ఇన్ ద రైట్ ఫిగర్ దిస్ గై వాజ్ pouring వాటర్ ఇన్ ద డ్రమ్ విత్ పైప్. సో ఇక్కడ మనకి వాటర్ సిమెంట్ రేషియో అన్నది మన చేతిలో ఉండదు. సో ఇటువంటి రాంగ్ ప్రాక్టీసెస్ మనం ఇప్పుడు కూడా ఎంకరేజ్ చేయకూడదు. నెక్స్ట్, సో డిటోరియేషన్ ఆఫ్ ది కాంక్రీట్, ఇట్ మీన్స్ disintegration of constituents in the concrete mix or degradation due to external media is known as deterioration of the concrete. Hence the reason many concrete structures are not withstanding to the original design life of the structure. The causes of deterioration in the concrete is mainly due to physical action, chemical action, mechanical action, and defects. In today's presentation, I am going to stress about the chemical and defects, chemical action and construction clause. Concrete deterioration concrete can be penetrated through its pores by gases like nitrogen, oxygen, and carbon dioxide, and liquid substances like water in which ions are dissolved. Permeability, concrete deterioration is influenced by the transport mechanism in the concrete. That transport mechanism is influenced by the permeability of the concrete. Let us go permeability. So next, in general, the term permeability indicates that the property of concrete to allow the ingress of these substances. The permeability of the concrete is not only important for water retaining structures like such elements like pipes, canals, and tanks, but It is a decisive factor in the durability of the reinforced concrete. In this schematic diagram of the concrete sample is illustrated about the concrete porosity and permeability. In sample 1 consists of 3 number of whites, but these whites are disconnected. On other case, in sample 2 consists of same whites, but these whites have been connected. In both the cases, porosity is same, but the permeability varies. For sample 2, the permeability was higher than that of the sample 1 because with the single reason of the connected whites is the in case. Next. This slide speaks about the strength, permeability, and porosity. If porosity increases, permeability of the concrete increased, and correspondingly, strength of the concrete was decreased. In this picture, speaks about the force distribution of the cement paste, which varying pozzolanic cement content is about 10%, 20%, and 30%. We can observe that significant reduction in pores in cement paste at 90 days. And finally, no larger pores, that is greater than 0.1 micron, was not seen after a year in cement paste, where the replacement level of 20 and 30%. This is primarily due to the secondary CS gel formation in the blended cements. The additional CSS gel in this system, this gel helps in pore refinement in the cement paste and makes the concrete more impermeable than Portland cement paste system. The porosity and permeability of the concrete will decrease over a period of time, that is take 28 days, due to formation of CSS gel formation during the hydration process to some extent in ordinary Portland cement. In blended cement, during formation of secondary gel reaction makes the concrete less porous and gets impermeable structure, which makes more dense and durable structure. Hence, the reason we are adding mineral admixture like the FEMs like fly ash, slag, and silica fume in making blended cements. Porosity and permeability of the concrete was more in PC due to the high heat of hydration at the early ages. It leads to permeability of the concrete. It leads to less durable structure. Next. Next. Chemical action is caused due to the sulfate attack, acid attack, alkali aggregate reaction, corrosion of reinforcement, penetration of carbon dioxide into the concrete, that is, can say carbonation, and chloride attack. Chemical deterioration mechanism that are carbon-induced corrosion, chloride-induced corrosion, and sulfate attack. Next. Next. Now, carbonation mechanism. Carbonation, it means carbon dioxide attacks the concrete. This picture concrete having some pores, and that pores have been filled with some pore solution. That when carbon dioxide ions way down into the concrete, it makes the pore solution to the carbonic acid. Again, this carbonic acid reacts with the calcium hydroxide. It forms calcium carbonate, which is insoluble product. During this process, this calcium hydroxide leaves some pores in the paste system. These pores from the carbon dioxide create some permeability, increase the permeability of the concrete as well as the decrease the pH value of the concrete. So, in this system, further penetration of air and oxygen into the concrete from the atmosphere into the concrete, it creates more problem to the reinforcement. It leads to some cracks in the column and spalling of the cover of the column. We can see passivated layer of the steel reinforcement and back side. Okay. So in this picture shows 4 number of concrete specimens cubes. Those specimens casted at site and cured at outdoor condition for 1 day, 3 days, and 7 days and 28 days to determine the carbonation depth of each specimen in real exposure condition. From this study, we came to know that the rate of carbonation is lower at 28 days cured sample compared to all the 3 specimens. It means curing influence the carbonation rate. We can avoid such carbonation in the concrete by curing the concrete as suggested by the IS code. At higher RH conditions, the pores in concrete have been filled with moisture. In such conditions, it is very hard to diffuse the gaseous ions into the concrete. Hence, the carbonation rate at the coastal region is very less compared with the other regions, where in coastal region, the relative humidity would be around 90 to 95. So in this figure, came to know about the carbonation rate was higher at carbonation rate ranging from 50 to 70. RH was higher concentration coastal region. Higher the humidity levels, lower the carbonation rate, which I was discussed previously. Next. How do we stop the carbonation? Make the impermeable concrete. Proper cover should be maintained as per the IS code. Use SCMs like fly ash and slag and other supplementary cementary materials to and maintain low water cement ratio. Use water reducers to make low water cement ratio, good compaction and proper curing. Next. This case study has been taken for this presentation is carbonation induced corrosion. This is staircase from road from rail bridge at Rajahmundry. Site condition was been reported that hot and humid conditions. Back. Site condition was hot and humid conditions and spalling of cover and corroded reinforcement exposures to the atmosphere have been seen. Next. From this figure, we can understand that carbonation process from this picture staircase. We can observe the spalling of the cover and the corroded steel throughout the periphery of the staircase. Back, sir.
Okay.
So back.
Okay.
Back.
Okay.
Okay. So further penetration of corroded ions into the concrete, which leads to the pitting corrosion of the concrete. In such cases, the reinforcement embedded reinforcement loses its diameter. So this is one case where we have reported and taken photographs near Kakinada. Recently, one apartment building columns have been restricted. During the time I have visited this site and taken some photographs, we can see that pitting corrosion was happened in main reinforcement parts. This is because of the chloride diffusion into the concrete. Next. So this is a case study what I am going to speak about. In this column failure is because of the sulfate attack and chloride attack have been reported. The sulfate attacks are from the groundwater. Actually, Kakinada region having a very sulfate-rich environmental in groundwater. And these sulfates have been the sulfate attack have been taken place by wick action and sorption, and chloride penetration have been happened due to some diffusion mechanism. So three transport mechanisms are involved in this case. So next. Next.
Next, sir. Okay.
Yes, sir. Back, sir. Back column.
Okay. Next, inka back.
So it is, sir.
Okay.
So this slide is speak about the chloride diffusivity of the cement paste and the concrete with various binder systems and with varying of water cement ratio. So ordinary Portland cement with 0.4 water cement ratio, there is a diffusivity is 2.6, and with 0.5 water cement ratio, diffusivity is 4.5, and 0.6 water cement ratio, diffusivity of chloride ions is 12.4. If you take blender cement, there is a 30% replacement of Portland cement. Take a fly ash at 0.5 cement ratio, there is 1.47. This is a huge variation between the ordinary Portland cement and the blender cement. At the same time, concrete, 100% concrete made with 100% Portland cement at 0.4 water cement ratio, the diffusivity of the chloride is 18. At the same time, 40% of replacement of the supplementary cementatious cement is like a fly ash at 0.4 cement ratio is 2. Value is 2. Diffusivity coefficient is very about to 80%. 80 to 85%, there is a variation in diffusivity of chloride ions. Next. This is pertaining to the chloride profiling of Andhra Pradesh. Everyone must note such type of profiling must be studied before designing the concrete. So almost all AP is concerned, almost all chloride ions is there in the shallow groundwater level. We must take necessary action on the type of selection of the cement. Nowadays, cement firms offering technical services at a free of cost with their customers. They are giving very good services like a chloride concentration test at the groundwater and pH test for water and some compressor of the concrete tubes to ascertain the quality of the cement. Such technical services are there. They utilize such services. Apart from that, cement companies have come up with very huge products with various combinations of mineral admixtures and percentages of mineral admixtures to fulfill all the requirements of durability as well as compressor strength is concerned. Next. sulfate attack, it is a common form of concrete deterioration. It breaks down the compounds of the cement paste, like cement plus water. So this attack is a direct attack on concrete. The main compounds for reasonable are calcium sulfate, magnesium sulfate, sodium sulfate, iron sulfate, potassium sulfate, and ammonium sulfate. Right. In these compounds, the magnesium sulfate ions is more dangerous ion. Sulfate attack is concerned. Types of sulfate attacks are main physical sulfate attack and chemical sulfate attack. Next. Physical sulfate attack means when salts precipitates at the surface of the concrete, that is because of the that is comes under the physical attack of the sulfate attack. In chemical attack, when sulfate salts are cement paste or creates some new compounds that are expensive and damage to the concrete. That new compound is calcium aluminum sulfate, also called atringite. This is most expensive compound. It creates cracks in the concrete. The paste, in such conditions, the paste is broken down and it becomes mushy. So such conditions happen in nowadays in collapse of distress of the column. In hardened concrete, calcium aluminum hydrate can react with sulfate. From outside, it forms calcium sulfoaluminate, which can cause an increase in volume up to 227%. That is very expensive. So that we are using low C3A content cement, SRC cements for the sulfate, where the sulfates are rich in the soil. Next. So, effect of water cement ratio in the sulfate rich environment. So, type 5 cement, that means SRC cement have been used for making this concrete beams. Have been placed 12 years outdoor conditions, and we have to determine the sulfate attack on these concrete beams. We observe that both the beams have been made with different water cement ratios and have been used sulfate. Even though we have used SRC cement, we found that 0.65 water cement ratio beams have been deteriorated. And water cement ratio at the 0.39, the beams have been not deteriorated faster than compared to the 0.69 water cement ratio. How do we stop this sulfate attack? Means, so ఈ పాయింట్ మీకు ఎందుకు స్ట్రెస్ చేస్తుంటే గవర్నమెంట్ ప్రాజెక్ట్స్ లో చాలా మంది ఇంజనీర్స్ కూడా ఎస్ఆర్సి ప్రిఫర్ చేస్తున్నారు. సో వాళ్ళు సైట్ కండిషన్ లో ఎస్ఆర్సి యూజ్ చేస్తే సరిపోతుందన్న పర్సెప్షన్ లో ఉన్నారు. సో ఎస్ఆర్సి ఆప్షన్ ఒకటే మెయిన్ కాదు. సో వాటర్ సిమెంట్ రేషియో అన్నది చాలా ఇంపార్టెంట్ ఫ్యాక్టర్. ఈవెన్ ఇఫ్ ఆర్ యూజింగ్ ఎస్ఆర్సి, ద వాటర్ సిమెంట్ రేషియో మస్ట్ బి ఇన్ control condition. Otherwise, there is no use of SRC in such cases. How do we stop this sulfate attack? Means make impermeable concrete, use special cements with low C3A like SRC, use FEMs like fly ash and slag, maintain low water cement ratio and good compaction. Next. So back. In fact, this table is briefing about the effectiveness of the supplementary cementitious materials with respect to the various environmental conditions. Fly ash, slag, and silica fume and metacolin giving excellent to resist the alkali silica reaction and chloride resistance and sulfate resistance. Except in carbonation resistance, all SEMs are given moderate effect on the concrete because SEMs, high content of SEMs in the concrete, it means there is a huge loss of concrete pH solution. Defects is caused due to design and construction errors. Defects due to bleeding and segregation, defects due to inadequate cover, defects due to poor quality material, defects due to incorrect mix design, defects due to incorrect quality installation, quality of supervision, design and construction flaws. These are the points in practical, the main causes of concrete deterioration. We must take care of these points, keep it in mind while execution of the project. Next. Design and construction clause. Well designed and detailed concrete structures will show less deterioration in comparison with poorly designed and detailed concrete in the similar condition. The beam column joints are particularly prone to defective concrete is detailing and the placing of reinforcement is not done properly. Inadequate concrete cover may lead to carbonation depth reaching up to the reinforcement, thus increasing the risk of the corrosion of the steel reinforcement. While we designing, we make sure keep it in mind that the concrete must be designed for 50 years. If you are going to design a building for 50 years, if we are going building for 75 years, then we should design the concrete cover must be as per the design life given to the structure. That it was happened to make the cover plate by impermeable, proper cover compaction and proper curing must be done. Nowadays the curing చాలా మంది ఏమంటున్నారు curing is waste of water అనుకుంటున్నారు. సో blended cements ఉపయోగించుకున్నప్పుడు మాత్రం curing is must and should as per the specified in the IS 456. Next. So, by improving the performance characteristics of the cover plate, by decreasing the permeability of the concrete, by using various binder types, cementitious material in the paste system to avoid ingress of ionic species into the concrete with proper compaction and curing at low water cement level. That's why FIB model code emphasizing to take such deterioration mechanism are taken into the consideration in performance-based design approach. The following combinations of deterioration mechanisms are incorporated in linked with the deterioration process have been linked with the performance-based design approach. That is carbon-induced corrosion, chloride-induced corrosion, and delayed effringent formation, DEF and alkali aggregate reaction. Nowadays, concrete is an extended family of the material. It is very different properties, characteristics as per the performance based specifications. Nowadays, we can make the concrete strength to minimum 2 MPa to 200 MPa, and high strength concrete, high performance concrete, ultra high performance concrete, fiber reinforced concrete, lightweight concrete, high density concrete. There are many varieties of combinations are there. Next. Next. Making such concretes with the new binder system is very easy right now because cement firms have come up with very advanced products with various combinations of mineral admixtures and various percentage of mineral admixtures. Now this picture shows about the current practices and the quality of control and supervision is concerned. సో ఈ కాలమ్స్ మన సైట్ లో తీసినామండి, చాలా సైట్స్ లో అబ్జర్వ్ చేసి నేను పికప్ చేసినవి. సో క్వాలిటీ కంట్రోల్ కానీ కరెంట్ రైట్ కన్స్ట్రక్షన్ ప్రాక్టీసెస్ కానీ మనం కరెక్ట్ గా అబ్జర్వ్ చేయలేకపోతే సో ఇటువంటి కాలమ్స్ వచ్చే అవకాశం ఉంటుంది. సో ఇటువంటిది మనం అవాయిడ్ చేయాలి. నెక్స్ట్, సో లేటెస్ట్ డెవలప్మెంట్ ఇన్ వేరియస్ కోర్స్. సో నెక్స్ట్, సో Euro norms చూసుకున్నట్లయితే దే ఆర్ ద ఫస్ట్ టు లింక్ ఎక్స్పోజర్ కండిషన్ టు deterioration mechanism. In British standards, prescriptive based requirements for 50 and 100 years. SA court prescribes requirements not as much depth of EN standards. So EN standards అన్నది మనకి ఇప్పుడు బాగా పాపులర్ అవుతున్న స్పెసిఫికేషన్ సిస్టమ్ అండి ఇది, ES క్లాసిఫికేషన్ అనేది. సో ఈవెన్ FIB మోడల్ కోడ్ కూడా చాలా ఇన్పుట్స్ ఈఎన్ క్లాసిఫికేషన్ నుంచి తీసుకోవడం జరిగింది. నెక్స్ట్, సో ఈయన క్లాసిఫికేషన్స్ లో కూడా కార్బనేషన్ ఇండ్యూస్డ్ కరోజన్ అన్నది ఒక క్లాసిఫికేషన్ ఎక్స్పోజర్ కండిషన్ అయితే ఇవ్వడం జరిగింది. సో ఈవెన్ లేటెస్ట్ IS కోడ్ రివిజన్ లో కూడా ఈ కార్బనేషన్ ఇండ్యూస్డ్ కరోజన్ కూడా ఇన్కార్పొరేట్ చేస్తూ ఉన్నారు. సో ఇన్ దిస్ రిగార్డ్ దే హ్యావ్ గివెన్ సమ్ కార్బనేషన్ కోఎఫిషియంట్ వాల్యూస్ ఆల్సో. నెక్స్ట్, so here I'm going to highlight up some upcoming IS code revisions. They have given some sub-classification in exposure condition, carbonation, induced corrosion, fluoride induced corrosion, structure exposure to seawater, structure not exposed to seawater, and the for normal structures, and fluoride diffusion coefficient also they are incorporating now. And not better note, it is better to mandate few durability tests for concrete for durable construction. Next, so either example and they have been used triple blended cement. They have used this construction fly ash of 13%, coffee 10% of binder have been used for superstructure of this politically for. With a stump of 100 mm. For pile foundations and all, they have given some durability parameters also taken into the consideration. Some water permeability is they have given for 5 mm. The pressure was 0. The maximum absorption is 1.5%. But in test results shows that 0.7%. RCPT value must be 1200 coulombs, but in site conditions we got 590 coulombs. The SCMs are used, that is fly ash has been 37%, fifth of fume 7% have been used for the pile foundations. Thank you, sir. Thank you very much for your patience.
Thank you. Sir, thank you very much, Babu Mahesh Garu. Now,
thank you, sir.
Thank you. Dr. KVN Garu has given good presentation regarding FRP polymers, sir, fiber reinforced polymers. KVN Garu chala detailed ga icharu. He has given what is the fiber reinforced polymers, what are the different types of fiber reinforced polymers, what are their strengths, what are their types of FRPs, where they are to be used, what are the functional requirement, where different types of FRPs are being used in detail. Due to some internet problem, Dr. KVN Garu presentation could not be continued, but the subject is very elaborative and very informative, sir. So thank you very much, sir. Now our Babu Mahesh Garu has presented in detail the transport mechanism. Actually, this transport mechanism of load is not studied in detail by so many engineers. A few engineers or a few research and academicians only more concentrate more on the transport mechanism of the load. In detail, our Babu Mahesh Garu detailed about the wrong perceptions of concrete construction procedures of the concrete. OPC is good, more water is good. These are wrong perceptions, so many wrong perceptions. And these myths, the wrong perceptions are to be rectified, sir. He has in detail carbonation effect, deterioration of concretes. In detail, he has given good presentation. We really, it is a scholastic presentation, sir. Similarly, regarding the case studies also in detail with the pictures and photos and animations is very, very Babu Mahesh Garu, really good work, sir. Similarly,
Thank you, sir.
he has presented something about calcium aluminum hydrate. Calcium aluminum hydrate is an enemy to the calcium hydrate silicate. Calcium hydrate silicate gives you strength. Calcium aluminate hydrate gives you expansive nature of the concrete, which causes expansion of the concrete and spalling of concrete, cracking of the concrete. Similarly, our Babu Mahesh Garu in detail has studied about the defective workmanships, defective and the case studies also. Very nice, sir. I thank you also, sir. Now I start so a small introduction regarding the construction chemicals, sir. Just I will start now. 1 minute. This is only introduction, sir. Sir, am I audible, sir? Is the presentation visible to you?
Yes, sir. It is visible and audible. No problem.
Yes, thank you. Now, just I am giving a small introduction about the concrete admixtures and chemicals. In the next session, in the live session or video session, we will go in detail about this. So I will show you a small video, sir. Recently, how regarding Sir, now that's in the video. It is recorded one apartment slab is being cast. The apartment slab work is in progress, sir. He is pouring the water in the miller at his own wish. It is more than 25 to 30 liters. So the water cement ratio is approximately 60, 50 to 60. 60. It is this lump is more than 20 or 25 centimeters. Just the concrete is flowing because of adding water. This is the apartment of each floor. 4 apartments are there. So it is 20 apartment slabs, sir. 20 apartments are there in the 5 floors. The slab is being executed in this manner. It is one of the apartments in Guntur. Say they are pouring the water for the workability, simply for the workability. There is no admixtures, no plasticizers, no water reducing agents, simply adding water. This is a major structure. Number one, sir. Here, so why we need chemical admixtures? To increase the mechanical properties, sir, there are different types of admixtures. To improve the mechanical properties, compressive strength, flexural strength, split tensile strength. What there are, say, water reducing agents, soap plasticizers, and so many other materials for increasing mechanical properties. What types of admixtures, chemical admixtures are to be used depend upon the mechanical properties which a designer defines. What are the physical properties? Physical properties means how we reduce the voids, number one. How we reduce the seepage. How we reduce the, increase the density of the concrete. How we decrease the permeability. All these things also, the physical properties also, on depending upon the defined physical properties, we use chemical admixtures like waterproofing agents or some other micro silica or some other things, sir. Next, what are the durability parameters? Durability parameters means ingress of saline water, effect of chloride, effect of sulfates, effects of saline water, effect of drain water also. In the most of the our urban areas, the groundwater is being polluted by the day by day due to the unscientific of our urban sewage system. The groundwater is polluted and salinity is became increasing. So that also our foundations and ground level beams are also affected. So what are the durability parameters? The designer, the engineer wants. Depending upon them also, we use different types of chemical admixtures, sir. We are also discuss on that. What are the service requirements? Is the building required for 100 years or 50 years? Or is the building service requirements are in adverse atmospheric conditions, in the sea coast conditions, or in the industrial zone? Depending upon the service conditions also, we have to define our chemical admixtures, sir. In the next session, all these things, sir, will be done in detail with the academic experts and the technology experts and with industrial experts. Only on chemical admixtures in concretes only we will study, sir. Thank you. Let us close the session, sir. Once again, I thank our yes, sir. Continue. చెప్పండి, sir. చెప్పండి.
Just 5 minutes to conclude my session, sir.
Yes, sir. Sure. Let us continue, sir. Let us continue, sir. Let us continue, sir.
Share అవుతుందా చూడండి, sir. Just
1 minute, sir.
Points అని discuss చేస్తాను.
అలాగే, సార్.
నా షేర్ అయింది, సార్. చూడండి.
అలాగే, సార్.
నా PPT షేర్ అయిందా చూడండి, సార్.
లేదు, సార్. ఇంకా షేర్ కాలేదు, సార్.
You can't share the content unless the host president makes you president.
Excuse me, sir. Your voice is not very clear.
Hello.
Narsimharao. సార్ సార్ మీ వాయిస్ బ్రేక్ అవుతుంది సార్. మీరు మీరు అక్కడ మీకు బహుశా సిగ్నల్ వీక్ గా ఉన్నట్టుందండి. వాయిస్ బ్రేక్ అవుతుంది, క్లారిటీ లేదు.
సరే సార్, అయితే నేను క్లోజ్ చేస్తాను సార్.
Sir, Association of Consulting Civil Engineers Kakinada chapter, sir, they have conducted a good session, and our SFG group also, they have done good exemplary work, sir. Our Durga Prasad garu explained in detail about the Association of Consulting Engineers. Next, our Sundarrao garu in detail presented about the retrofitting, repairs, and reconstruction of the building, sir. Dr. KVN garu, his presentation is very good, sir. His PPT is very visible, but due to some internet problem, even though the audio is not clear, these different parameters regarding the FRP in detail, types of FRP and all those things, types of uses and all those things, characteristics in detail is presented, sir. Similarly, our Anil Kumar Pillai about the blended cements, about the durability of the cements, types of cement to be used depending upon our conditions and all those things. Anil Kumar Pillai of Ramco in detail has presented, sir, very good presentation. Our Babu Mahesh has done good exemplary work on the transport mechanism, deterioration of buildings, carbonation, and misconceptions and wrong conceptions, case studies, defective works, and also, sir. I thanks once again, sir. Anybody wants to present anything or talk anything, very feel free to talk, sir. Anybody can interact, sir. Sir, am I audible? Any participant? Hello? Anybody can want to present anything or ask any doubts from the experts? You can ask, sir.
Hello, good afternoon, sir.
Sir, good afternoon, Chapandi.
Sir, this is PS Muralidhar from Bihar, Chhattisgarh. It has been a very wonderful session, and I came to know from an engineer about this program, sir. I thank the organizers. It was a very wonderful one. Thank you so much. Hope to hear many things in the days to come. Thank you very much.
Thank you, sir. Thank you so much, sir.
Anybody can express their views or give suggestions for better performance in future.
నాయుడు గారు చెప్పండి.